Hello, check.
Hello, everyone. Very warm welcome to the fourth FC Kohli Day at IIIT Hyderabad. For the last 4 years, we've been commemorating the birth anniversary of Padma Bhushan, Shri FC Kohli, by showcasing our research and innovation. This year also, we have a very short and sweet event with 2 keynotes and a power-packed panel discussion. This year also is a very special year. This is the birth centenary of Shri FC Kohli. And we had Mrs. Swaran Kohli. We had invited her to give a short message online. But unfortunately, she's unable to join us today, which would have been really special if she had done so. So let me ask our director, Professor Vijay Narayanan, to come and say a few words and open the event.
Good afternoon and welcome to this event. So you are sitting in the Kohli Research IIIT inside the Kohli Auditorium and for the FC Kohli Day. So 19th is when 1924 is when he was born in Peshawar, which is now in Pakistan. I think Mr. Kohli really needs no introduction. We all owe a little bit to him for, we means anyone in the IT, software, computer industry in India, which has really propelled India forward, the economy, the impact of the economy as well as international relations has been unprecedented in the last 25, 30 years. And that whole software or outsourced software industry started with Mr. Kohli's brilliance. He was in Tata Electric first, then they started the software division, which was later named TCS, Tata Consultancy Service. And he's been, ever since 2015, this KCIS or Kohli Center on Intelligence Systems were announced here in IIIT, and for the foundation stone kind of event, we had Mr. Kohli himself came, Mr. Kohli and Mrs. Kohli came, but also Cyrus Mistry, then the chairperson of trusts, had come, and of course Mr. N. Chandra, who was then the CEO of TCS, he was there, and the whole array of TCS people were here. And after that, several times, Mr. Kohli and Mrs. Kohli both visited the campus. Whenever he comes, he wants to meet the students, he wants to know about some of the developments. He'll spend half a day. Typically, we schedule a 2-hour session with some students and research updates, and they take great interest in listening to all that. And he also told me, I will visit IIIT, just invite me. And whenever you invited, he'll come. So he has, one of the lines that he says, which we should all keep in our mind, is he says, India, with its great richness in culture, in human resources, in everything else, India has no business being poor. This is how he puts it. Business being poor, and if you are poor, if you are not rich, that's only our own making, and we should reverse that. And that he did that. He worked very strongly towards that, of course, as part of TCS and other things, but also later in various committees or government advising to the government, or part of several education, notably the COEP in the Pune. He worked with that zeal, and he also always tell us good things which really transformed the society. And I would also like to say a little about Swarn Kohli. She also used to come. She also take a lot of interest in what we are doing here. 10 minutes ago, she sent a message. I'm not able to, at 3 o'clock, sent a message. I'm not able to join, excuse me, something. We're not even sure if the message was meant for us, so we've been trying to call her to see if it was, by mistake, but even now she called, she's not able to join, looks like. But she has also taken a lot of interest. Swarn Kohli, of course, is, always known as FC Kohli's wife, but she's an activist person herself. There is a thing called NPCCA, that is Nariman Point Churchgate Citizens Association. It's been fighting for several, that Nariman Point Churchgate, you can imagine by how citizens have learned to protect parks or public lands being, taken away by for commercial interest. So she has been very active. She's been the president of NPCCA for many years, and had a major victory in space that was allocated for something else. They reclaimed it, and it was transformed into park. And it was, I think that happened a few years ago, but the formal inauguration of that happened just last August. And there was, I could see that on the newspapers, how they, the event which attended by the Deputy Chief Minister of Maharashtra, Devendra Fadnavis, and so on. So she her own independent interest and activism, which is also very nice to see and a good lesson to all of us. So Mr. Kohli has to be a guiding light for all of us because of his unstinted devotion towards, removing the fact that, India, which has no business of being poor, towards that or moving towards that. So I think let's remember Mr. Kohli and his enthusiasm, not necessarily the person, but the message he stands for. And it's an occasion to reaffirm that message. March 19th, this is the 4th year that we are conducting this event, ever since we had the Kohli Center inaugurated and so on. So I welcome you all. We have a fantastic program curated by Nimi and Madhav Krishna, who could not be here due to his personal reasons. So I'm looking forward to the program. I don't want to say too much. Thank you very much and enjoy the day.
Good evening, everyone. Welcome to the first event for the day. We are honored to have Professor Satyanarayanan Chakravarti to deliver the opening keynote. Satyanarayanan Chakravarti is a professor of aerospace engineering at the Indian Institute of Technology, Madras. He is the co-founder of E-Plane, Aerostovelos, and Agnikul Cosmos, and also the founder and head of NCCRD, National Center for Combustion Research and Development. It develops state-of-the-art capabilities in combustion research. It is the world's largest combustion research center. Professor Satyanarayanan is deeply passionate about deep tech entrepreneurship to democratize technology and works towards ushering an era of defrastructure, a notion that challenges the need for large infrastructure for economic emergence with an alternative based on exponential technologies and fosters sustainable development. Professor Satyanarayanan has been a recipient of many awards, beginning with the HAL Prize for Best Undergraduate in Aerospace Engineering in 1991, followed by the DRDO Academic Excellence Award by the Defense Research and Development Organization twice, in 2009 and 2016. He recently was awarded a Deep Tech Enabler Award by TIE Chennai in 2022. So, we are honored to have you here today. I now invite Professor Satyanarayanan to deliver the opening keynote. Thank you.
Would this come here? Hello. Yeah. Hello. Yeah. Good. Thank you so much. Thanks for calling me here. I was quite um, impressed with all laboratory facilities that I just saw, and feel like we should actually be collaborating a lot more. So I was thinking that I should probably to Madhav Krishna and ask him back in my team to meet with your students here, maybe for a day. I could have spent more time. We just didn't have that kind of time, so we had to come here for this. What I'm going to be talking about today is the future of urban air mobility in India. So just picking up on the goal or the zeal that Mr. Kohli was actually talking about, that India has no business being poor, this kind of looks like it's all meant for rich people in India. The reality, I believe, is actually somewhere in between. We believe that we have a very large middle class in India, and that middle class is probably the population of America and Europe combined, and that's actually a very mighty economic power by itself for the class. So that's the basic idea over here. So we don't want to essentially pander to the rich nor to the poor. We want to do something here technologically that would make sense to the middle class. That's the context in which I would like to present what I am talking about. Might have problems with audio. Pardon me if that's the case. Or it's possible that this video does not have any audio. Either way is fine. So essentially, we are looking at how we could go from place to place within a city or across a city by planes instead of by roads and metros and so on, which require a significant amount of infrastructure, whereas the kind of infrastructure that you require for something like this is fairly straightforward. It just to oversimplify it. But let's see if we can quickly. Okay, I think I'm now. I still don't have this working. Okay, now it's okay. I think I'll probably just use things directly here. It's easier to make planes than get these things to work, I guess. Yeah, so what's the global scenario? We do have, as we speak, none commercialized yet. This is something that I want to essentially pitch to you, right? So if you are on the other side of 40 or 50 years old, you have the curse, which I actually call the brown curse, that you always think, has it been done somewhere else? Should I actually then start thinking about doing it again? If you're on the better side of a 40 or a 50, which you're much younger, hopefully you belong to that generation in India which doesn't have to worry about whether it's being done elsewhere. And what we are doing here is sort of in that bracket where we are kind of doing this alongside the rest of the world, which means that we could probably be at worst maybe about 2 years, 1 year, 2 years behind the rest of the world. So this is not commercialized anywhere yet, right? And there is a likelihood that we might commercialize this first in India. If all the stars align, everything goes well, we might actually do this first in India when compared to others. But we're not actually in a race. We're just doing what we want to do, and we have to get to do what we have to do, and so on. That's essentially the point, that you're having multiple people taking a stab at it. Many of them are actually very successful, still plodding through what needs to be done further, and we are pretty much part of the same game. There are two things that we should actually be worrying about, just in case if this sounds like a little bit of Greek and Latin. eVTOL stands for Electric Vertical Takeoff and Landing Aircraft, and that's what we will be talking about for urban air mobility, UAM. So two parts to this primarily, which is eVTOL development and certification. It's kind of like a 10 billion USD investments that have happened in the last 10 years, perhaps. And the second part is actually a UAM infrastructure, where this has kind of happened a little later. And there are people who are collectively putting about 25 million USD, much smaller amounts at the moment. But it also probably is much smaller amount when compared to the eVTOL itself anyway. And operations expected to start in 24, 25. This actually keeps getting pushed every year to the next year, and that's how it's been at the moment for the last couple of years. This is a picture we're actually extremely familiar with in our part of the world, not so much in other parts of the world. So if you have to ask the question, who needs eVTOLs the most? Who needs urban air mobility the most? It's actually the Indians, right? If you're an American, in fact, there are opinion polls, surveys that actually bear this out repeatedly. People in different parts of the world, advanced countries, saying, not really interested in urban air mobility, right? Whereas you ask an Indian, they'll say, yeah, sure, we want to actually get on one, right? So this is actually where the need is, and this is where we need to step up the game on the technology, right? And many times I also see that that's a curse that the developed world has, that they are developed, right? That means past tense, right? There is no future, right? So we are developing, that means that we are continuous tense, right? It's present continuous tense. That means that a lot of action happens here in this part of the world, right? This is actually the happening place. So we need to actually look at what's appropriate tech for a place like India, where we have these kinds of problems. Traffic actually holds people up who care for their time, as well as we're also actually guzzling a lot of fuel, holding cargo up from moving faster enough and so on the roads. In fact, if you think about it, I mean, the 6-lane highway opened up barely about 10 years ago between Chennai and Bangalore, and it's clogged with trucks. Exactly the same kind of a 6-lane highway, or even less, a 4-lane highway in the US will have trucks, but not as dense. So, and then you're taking a car thinking that you can actually go from Chennai to Bangalore in about 5 hours, and you have to actually wade through these trucks because these truck drivers don't have the discipline to drive on only one lane of the road and then allowing faster vehicles to move and all that stuff, right? That's a third world problem too, right? You're not here to preach behavioral, methods for the drivers and all that stuff. You have to live with that. And so what do? Well, why don't we think about flying instead? That's what that's the idea that we are talking about. So, a little bit of business sense before we actually get into some technology. How big is this market? We actually commissioned a survey of about 12 cities in India through Frost & Sullivan, and we actually got some primary research done and granular level data down to tier 3 cities, right, in different parts of the country, northwest, east, and south, and got respondents to tell us whether they are okay with a urban air mobility play for both cargo as well as customer, that is passengers. And based on that, I think Frost & Sullivan tried to develop a commercial model, and they tried to integrate this data with the global data that they already had for other places in the world. I mean, not much. It doesn't take much to guess that Frost & Sullivan didn't care about India at all in the first place, and until we actually told them, hey, why don't you care about India? Because we are here in India, we need to figure out whether we have a market here or not. We know that we have a market, we have a hunch that we have a market, we have anecdotal evidence that the roads are clogged and we need to definitely fly, but and then people are asking questions like, can we afford it and all those things, and we think that we can actually afford it, but can you go and find out? And they came back and said that you have a $200 billion total addressable market in India itself by 2040, which is about 20% of the global TAM. And just to give you a comparison, they estimate that US will be about 23%, China will be about 26% of the global market, and so on. Look at the demand. I think there is some demand graphs also, something that I had. I think might come up a little later. So yeah, this shows a little bit more granular level of detail. Hyderabad actually figures in that, for example, right? So we didn't bother about Chennai. Chennai is actually a great city. You don't need much open air mobility at all. You can get from one place to the other in 15-20 minutes, half an hour. Less crowded. Right, but Hyderabad looks extremely amazing. Like so many flyovers and highways and all that, but still probably at the rush hour or whatever it is. We have all of this data. I think the more important point is summarized in the next slide, which is looking at access, operating mode, service type, capacity. All of this primarily validated our hypothesis on how the product should actually be serving an Indian situation, which is it needs to be extremely compact. A plane that can actually land on this days, if you can, right? So that kind of thing. Definitely within this hall, and so on. And operating mode, human piloted, service type should be a personal taxi, and evidently then a two-seater actually wins over more seats in the aircraft. And the kind of uptake that we have onwards going up to 2040 is like midterm, around the end of this decade, 2030, India is estimated to actually have about 198 million trips per month, right, across multiple cities. Is right, actually a mind-boggling prospect that we're talking about. So let's actually now look at what does it take for us to actually get there, if it's possible for us to get there at that scale in the first place. About 5 problems and short haul or urban air mobility. We can call it short haul versus urban. We can actually do this in rural areas, remote areas, hilly terrain, those kinds of places as well. So what are the different themes that we need to actually be looking at, right? So the first one is the elephant in the room, which is the aircraft itself. Do we have an aircraft that actually can do the job? Does it cut it, right, for an Indian situation? So the design, the prototyping, the testing, the certification, all of that stuff. The more important thing that everybody actually starts asking questions on, hey, how do you do the air traffic management? Right? Are we going to actually have around the end of this decade, 2030, India is estimated to actually have about 198 so only, and this can't stop mid-air and then start shouting at each other, right, across these multiple cities. So how do you do this, right? And right, actually, mind actually starts asking questions on, hey, how do you do that? So and where do we land, right? And then, right, are we going to landing places like? So we have these new jargon shouting at each other, and so on. This can't stop mid-air and start shouting at each other. These are problems. What about how do you do this, right? And facilities, no, we won't do that. The maintenance, repair, overall facilities. So and where do we land? Supply chain, right? So what are the landing places like? So we have these new jargon called vertiports, 2 or 3 of these topics, not all of them. Maybe I'll just touch upon a little bit about piloting and stop there for now, because we are not able to foresee 5 years down the line on something that's actually rapidly evolving, spares and all of, right? So Right now,
I'm
we are
going to
actually
talk
fixated on
about
looking at the
two or
plane,
three
the
of
making the
these
aircraft.
topics, not all of
We are
them.
thinking
Maybe I'll
about
just touch upon a
these,
little bit about pilot training and stop there for now because we
the
are not
air
able
traffic
to
management and
foresee
the landing
5 years down the line on
basis.
something
We have
that's
some
actually
ideas
rapidly
about pilot
evolving
training
in the space.
So I'll
right?
just share my
right
thoughts
now
about
we are
how this is
actually
going to pan
fixated
out
on looking at the
in the
plane,
next
the making
few
the
years
aircraft
in India.
we are
Thinking
that is, of
about
course,
these.
right? So first we'll actually talk about the eVTOL itself,
the air
which
traffic
will
management
be
and the
about
landing
aircraft, the design and the
pieces.
certification.
We have some ideas about pilot training.
We'll start with the video.
So I'll just share my thoughts about how this is going to pan out in the next few years in India, that is, of course, right? So first we'll actually talk about the eVTOL itself, which will be about the aircraft, the design, and the certification. We'll start with the video. Thank you. Okay. Thank you. So, yeah, let's actually compare how we are faring with respect to other people around the world, right? So we always have to worry about, are we doing it right? And it's very important for us to actually have a hindsight advantage, right? So if I started a couple of years later, I need to actually be doing better than the other people who started a bit earlier. So on the one side, you actually have what we essentially are talking about is like glorified drones. Am I getting this? Okay. Yeah. So glorified drones, which are essentially multicopters, and which essentially means that those vertical rotors will have to be running all the time to hold the to balance the weight of the aircraft, and they guzzle that power. So they have a very short range. So typically about 20 kilometers and so on, which is good. Right? 20 kilometers is a good distance for you to go from here to the airport, for example. Except that, let's say you can actually do this in about 10 minutes, whereas an airport ride from here might take about 30 minutes, 40 minutes. That's good, but typically these are two-seaters with one pilot and one passenger. So one paid passenger actually goes from place to place in about 10 minutes, and then you have a downtime charging for the next 1 hour. And then so after 1 hour, the plane actually takes another person and then has a downtime charging for an hour and so on. So 10 minutes flight, 1 hour charging, 10 minutes flight, 1 hour charging. Pretty bad asset utilization. So in order to alleviate this, we aerospace engineers don't think of these as just electronic gizmos, right? So the drones are essentially basically electronic gizmos. You just had stuff, the juice go to a motor, and the motor has a propeller, then it starts flying, and then you have a flight controller, and then so on, right? Whereas we want to have wings. And is it possible for me to actually generate aerodynamic lift so that I'll be able to manage the weight of the aircraft by aerodynamic lift, right? And I just have to incur only the power to overcome the aerodynamic drift, but much less when compared to the lift. Therefore, the kind of power that you will be guzzling will be much less is the idea. Except that for the wings to be effective in generating the lift that you want, you end up actually flying fairly fast. So typical aircraft that we know fly at about 800 plus kilometers per hour, and these aircraft actually fly at around 300 plus kilometers per hour. And at 300 kilometers per hour, you still are actually flying too fast that by the time you're actually kicking off, accelerating to that speed, flying for a distance, and then decelerating back to halt and then descend to vertically to stop, you would have probably covered about 50 kilometers. And that takes you outside the city. India actually has some of the largest cities in the world, and typical radii of our cities is still only about 30 kilometers. Right? A lot of other cities are actually much, much smaller. So if you have a plane that will actually take you outside the city, but not to the next city, you're actually going nowhere. Right? And that's the problem that these guys have. So basically, aerospace engineers have this problem. I'm an aerospace engineer, so I kind of know this. They are so enamored by what they make, they don't care about whether it's useful or not. Because it's like so good, right? If normal people don't know how to use it, that's their problem. They're lesser mortals. Right, so this is the typical attitude, particularly when you have a lot of money coming from the West, right? Whereas Indians are actually a lot poorer, which means that we use our head and ask the question, yeah, it's all great, but what's the use, right? What is the point? Who is going to use it? Who is going to pay for it? That's the question. So we think through what is required for doing this. And there are two requirements. One, it has to be extremely compact, whereas these guys are actually about 12 meters in width. Even this one, for example, actually has this huge ring with lots of small rotors. It's about 9 meters in width. The question is, where will they land? Right? You need to have very, very specific areas in which you have to land. It's very large spaces. That means you have to actually go from where you are by road to that place and then take a flight outside to somewhere outside the city, and then you land somewhere there, and that's not your actual destination. So you have to go by road again. That's a three-legged journey that only halves your travel time. It doesn't actually cut down the travel time by a factor of 5 or 10. So we need to be extremely compact. That's one. And you still have to have wings, because you need to have this thing that the wings will have to balance the weight of the aircraft and not have these vertical rotors take the weight. The second thing is you have to also fly very slowly. You have to fly as slow as these guys on the left, right? But you have to have much compact wings than the guys on the right. That's a challenge, and that's an aerospace challenge. You will not find a glider that has very, very wide wings flying very fast that actually flies very slowly, whereas a fighter aircraft that flies very fast actually can have very compact wings, because the wings generate lift. Faster you fly, you don't need a very large wing and so on. This is a contradictory requirement. We asked the question, but we have this VTOL. What are these vertical motors doing in forward flight? Is there a way by which I can utilize them? And so on. So we have actually an IP around this that makes us the world's most compact, slow-flying winged aircraft. That allows us to actually go not just one long trip in a single charge of battery, but multiple short trips in a single charge. And that's typically how a typical taxiwala works. Okay, and you have to say, you could be an aerospace engineer making the best aircraft in the world, but ultimately at the end of the day, you're just flying a damn taxi. Right? So you have to actually figure out, what does it take for you to be a taxiwala? And can I actually be better than the ground taxiwala? The ground taxiwala is actually still stuck in traffic. So maybe he does about 10 trips of about 20 kilometers each, 20, 30 kilometers each. I can do 50. Because I actually go by the air, I do each of these trips in about 10, 15 minutes, right? So I actually do 50 trips. So we have a much, much, much better asset utilization, very good unit economics. What's that unit economics, right? Bangalore is actually the worst city to pick, right? So in the world, so we have all these world extremes that we have, right? So, this is actually a 30-kilometer radius around Bangalore. That covers pretty much all of Bangalore and its suburbs. That's a very typical route from MG Road to the airport. It's about a 30-kilometer. You pay 1,500 rupees Uber, not Uber Go, not even Uber Premium, no surge pricing, nothing. 1,500 for this kind of a trip, and very likely get stuck for about 2 hours in traffic, whereas you can actually do this in about 15 minutes at about 2,700 rupees. And at 2,700 rupees, I'm still actually making more money than what I'm spending. And it's actually a fairly profitable business to be in. What about the sustainability? Because we are able to have a huge throughput in terms of carrying people or goods very fast with every trip, within 10 minutes, 15 minutes every trip, on a per kilometer kg basis for cargo or per kilometer passenger basis for people, we can actually look at being the lowest in terms of carbon dioxide emissions. And we are not looking at aviation emissions here. We are actually looking at competing with road emissions that we are trying to cut down and essentially bring down global warming and so on. What's the certification outlook, right? So we have a very straight path to certification because we have separate vertical rotors and forward rotors. So it actually adds to the redundancy there. No tilt rotors, so there is no critical mode of failure. It's human piloted, multiple rotor redundancies, parachutes and inflatables for soft landing, partnerships with certified suppliers for components, expected to be certified as a powered lift plane and not as a helicopter, and to enable all weather nighttime operations subject to gust resistance, etc. So we got the design organization approval last May. We're the only private company in India to actually have a design organization approval for designing a full aircraft, all carbon fiber, electric, and so on. And we have like about a 3-year roadmap to actually get this certification complete by mid next year, or end next year, let's say. Things keep drifting, as I said, in this game, right? So we expect that we should actually be airborne commercially in a couple of years from now, let us say. That's actually the aircraft. What about the airspace management? What is the UAM corridor? What is the flight path authorization? What's the ATC like? So today we have the general or the commercial aviation above 5,000 feet above ground level. And we also have the drones that are actually coming up, which is below 400 feet, AGL. AGL is above ground level. So in between, we expect to actually have a UAM corridor, which will be somewhere between about 500 meters to about 1,500 meters, or let's say about 1,640 feet to about 4,900 feet. That's about the UAM corridor that we will be looking at, which keeps you away from drones, which keeps you away from planes. That's the idea here. We will take off vertically a little bit, and then we can actually get into an inclined climb like a typical aircraft, except that here we take the assistance of the vertical rotors as part of the climb a little bit, and then when you get to a point where the acceleration is complete, you're still climbing, the wings can actually generate lift like a normal aircraft, therefore the vertical rotors can power down. So you have that kind of a handshake which has an overlap that is redundant. so that you're not losing lift at all at any time. And then you get to your cruise altitude, and then you fly at constant altitude, and then go through the reverse process of a descent, a wing lift based descent, followed by a vertical rotor based descent. Get to the point of where you want to land. We have computer vision based precision landing algorithms that can pick up a QR code on the landing site in order to be able to precisely land within a centimeter or two, that kind of thing, right? So that's a basic idea here. So if you were to, this is the typical flight path. Now, if you were to actually have multiples of these aircraft that are going to do this, then we want to make sure that each of these flight paths that are connecting any destination pair should not intersect with any other flight path that is going to any other destination pair. Therefore, we will by design not have any two aircraft collide with each other at all, right? So in some sense, let's say you want to actually go from, I don't know, let's pick two places, two places that naturally come to me are Begumpet and Shamshabad, let us say, right? So if you're actually going there, you are essentially saying that I will always use that particular flight path to go between these two pairs of destinations all the time, right? That means you get a separate road for yourself for going from Begumpet to Shamshabad, right? That's the kind of thing that we are looking at. So we will essentially mean that we get these fixed flight paths which are non-intersecting, but as we keep growing, right, in terms of density of number of points and so on, we may not be in a position to have these fixed flight paths. So we will have to kind of dynamically generate flight paths. We will also actually have to dynamically generate flight times to make sure that aircraft do not intersect each other, flight paths do not intersect each other, right, dynamically. So that is something that we expect will happen much later through the end of the decade, but somewhere in the next 5 years, we can actually work with a fixed flight paths idea. Progressively, we expect that even by about 2032, we could get all the way to a fully autonomous aircraft. As a matter of fact, what we do today is a fully autonomous aircraft. It's just that by regulations as well as for public accidents, we will have to step back and then position all these as pilot assist features rather than kind of like ADAS, right? Or autonomous driver assist systems in cars. So instead of actually having a completely driverless car, we will actually have a significant amount of pilot assist features that stand in place of fully autonomous aircraft. The question then we have to ask is, how do you deal with airports? So when the big planes will have to land and take off, how do you do this? The answer is, those actually take off and land along a certain flight corridor because they are aligned to the runways. So we know the runway orientation, so it's okay for us to actually be able to come perpendicular to the runway and stop. I have to actually maybe start from the other side of this corridor perpendicularly and then go out. That's okay, but I cannot cross. If I want to cross, I have to kind of go around these cones that are kind of like this. I have to duck around and then go and so on. So that is actually the flight path that we will have to take in order to not intersect with the aircraft corridors within this particular altitude zone that we are operating in. What about drones? What will the drones do when you're actually having these UAM? Just like how these smaller eVTOLs actually are ducking the flight path of larger planes, drones being smaller than eVTOLs, they will have to kind of duck around the flight paths of these eVTOLs. As at the level of where the drones are, the flight paths of these eVTOLs will be typically vertical. So they're going to be either landing or taking off vertically, and that will be within a vertical cone, and you have to essentially have drones that go around these. We want essentially mandated in such a way that that's kind of like a red zone. So drones will have to actually go around them, even when there is no plane, there is no, it's kind of like a local airport, right? I hear that minus the stadium, you have 70 acres of land, right? You probably should actually make room for about a 2,000 square feet flat piece of land. That will be your, takeoff and landing site in the next few years for you to bring people in. The next time I come here, maybe I should come by my own plane. Okay. That means I'm not coming anytime soon. Right? But the point essentially is that that becomes like a local red zone, and drones are supposed to actually fly around those instead of cutting across. That's kind of the airspace management that we have to do. What about the landing spaces? So the regulations require that you need to have about 1.5 times the maximum dimensions of the aircraft to be what's required for the landing space, which is where the 2,000 square feet. 2,000 square feet is like about a 3-bedroom apartment, right? And what did I tell you? We're talking about the middle class, right? So we essentially can land on top of 3-bedroom apartment buildings, essentially. And so, I mean, of course, today the terrace is actually taken by solar panels most of the time, and we also actually have a lot of other utilities like overhead tanks and all that stuff. But we're talking about, like, let's say you have 4 apartments to a floor, the terrace is actually going to be more than 2,000 square feet, right? So just get one corner for me and then I'll be done. So we have conceptualized about 4 kinds of landing sites. The first one is kind of like, boutique hubs, where we will have multiple aircraft that are coming and landing and charging with slow chargers, for example. Right, so this could be a space for about 6 to 10 planes, which could be parking lots, rooftops of parking decks, malls, metro stations, and so on. The next one is actually for something like about 2 to 3 planes, which could be vertiports. That could be existing helipads, rooftops of smaller buildings, fronts of malls, and so on. Then you can actually have a verti-stop, and we could come up with a very, very compact public verti-stop, which is like having just one pillar, which has a lift shaft for you to go up, and then there is a flat top there for you to take the plane and go, or maybe just another floor for you to wait in a small lounge or something of that sort. And then, of course, you also have private verti-stops, which is your apartment buildings, right? And these will have to go along with their respective charging infrastructure, the slow charging for the hubs, the fast charging for the ports, and the rapid charging stations for stops, but probably no charging infrastructure at all in these private verti-stops. So again, a video of how you might actually have one building with a rooftop which can take about two aircraft, and one of them flies off, the other one lands right after that, and so on. And similarly, using existing public spaces like metro station rooftops. For some reason, metro stations are not really having flat rooftops at all. So it's about time we actually go and talk to those guys and say, dudes, why don't you just flatten your rooftops? We can land and get people to go to their homes pretty quickly and all that stuff. Last bit that we would like to actually talk about is who are the ones who are going to pilot this. It's a huge market, again, about 1.2 million eVTOL pilots needed by 2040. These are actually more automated, so easier flying and lesser workload, and much shorter missions, right? So more critical phases of. So takeoff and landing is actually the biggest problem for pilots, right? Forward flight, the plane is designed to fly, right? So it will do its job. Right? This is also true for cars, everything, right? So our body is actually meant for us to work, not to sit, right? So cars are meant to move on the road, right? That's how we designed. You think about how your professors actually teach, they will actually talk about things on the move, right? What it's supposed to do. Major problem is transient. How do you get from a state of stationary, position to a motion and then come back down? That's where we need to have more pilots and so the pilot attention. And we are actually now thinking about a taxi, 50 trips a day, right? Kind of thing. So the pilot fatigue would be there because he or she is actually now taking off and landing too frequently. That's not something that normal pilots go through. And it will all be single pilot operations because we are actually, this guy is actually costing me money, right? So I can't afford to have any more than one pilot over here. So these are the issues that we are looking at. So we have a heavy pilot assist capability so that the pilot doesn't have to do anything. And these are very relatively easy to pilot, extremely stable planes is the idea here. Obviously, we want to start with simulators and then transition to flight testing. That's way by which we can make it a bit inexpensive. The second thing is electric aircraft are actually inexpensive. So in fact, my passion is if you make electric aircraft that are not even VTOL, they are conventional takeoff and landing two-seater electric aircraft, we will bring down the cost of pilot training and therefore we will pay less for me to come from Chennai to Hyderabad and go back. Okay, so that is the future that we should be going towards, and we believe that that can help in bringing down. The other way to do this, with now eVTOLs coming in, can we actually talk to the certification agency and say, if these guys actually pilot my planes, will they clock hours being a commercial pilot while getting paid for it? Right? So that's actually a value proposition for us to bring down the cost of pilot training even more, so that normal aviation will actually become cheaper. So we do actually have flight simulator plans going forward. And yeah, I think that's all I wanted to say about pilots. So concluding remarks, right? So I think I started with this note: India is at the cutting edge of urban air mobility along with the rest of the world. So get used to the idea that we are actually doing things at par with the world or even ahead. There is a likelihood of us getting there to operations even slightly ahead of others. Being very cautious in pushing this idea here. Multiple aspects need to be considered besides the aircraft, air traffic, landing sites, pilot training, etc. The Indian government agencies are actually seized of this matter and have already set up working groups and committees to go into all these aspects. And we plan to operate a sandbox very soon. Very soon could be later this year, early next year sort of time frame to demonstrate the viability of urban air mobility in India. So that's the future for you guys. Thank you so much.
Thank you, Professor Satya. Very exciting talk. Usually we let off keynote speakers without a Q&A, but due to popular demand, we are going to take some questions.
That's because I did the cardinals enough finishing minutes earlier.
We can talk now.
Absolutely. So we believe that pilotless operations will actually happen before driverless cars. Okay, simply because there are two parts to this, right? So one is the obstacle course while takeoff and landing. So we are already demonstrating precision landing in a few centimeters accuracy, number one, right? So landing is a bit more tricky when compared to takeoff, but this is where we have the obstacle course around you, right? But when you now get into overflight, there are hardly any obstacles, but you might have dynamic obstacles. You might have bird flocks that are coming there, or you could be having other drones or other aircraft, and so on. So we actually work on systems and autonomy with a sense of speed and sense of fusion, computer vision algorithms, monocular depth perception with cameras, all of these things, cameras, radars, how do you mix all of that stuff for a 360 steradians, not just in one plane, situational awareness, right? And we switch from a segmentation-based models for obstacle detection to attention models for forward flight and so on. So we do all of this stuff that makes our aircraft quite possible to do fully autonomous operations, except that we don't want to push our luck with the regulating bodies as well as the public. So in fact, our goal is to essentially have the passenger sit next to the pilot and have a transparent wall in between for the passenger to watch the pilot not do anything and then ask the question, why am I paying this guy for not doing anything? Is it possible that we can actually get rid of him and then save a few bucks? When people start asking that question, we will do it.
Thank you, sir. Thank you, sir. That was great presentation. I would
Yeah, I think we can ask this. So, thanks for specifically talking about the compactness and all that stuff that Chetak's have. Not doing this job now. That's a simpler question to ask. Okay, the answer is I got introduced as having founded and being the head of the world's largest combustion research center in IIT Madras, right? And the problem is combustion is expensive, right? So if a combustion-powered helicopters, first of all, actually have a very poor safety record, simply because they have one hub, one rotor. If something goes wrong, of course, if you have the propeller intact but the engine failed, you can actually go around in a what's called as a auto rotation mode, and then you'll be feathering. You won't actually fall in a thud and all that stuff that is there. But what if actually the propeller blade shipped off, right, during takeoff or whatever it is, right? So you have a single point failure over there, and helicopters do actually have. It's a very it's a mechanical engineer's delight, an aerospace engineer's yuck, right? So we guys don't like moving parts at all, right? Here you have these swash plates. There is like pitching will change as it goes like this, and all kinds of nonsense. You see, I don't know like how many mechanical engineers there are. Their instinct to have T-shirt designs is full of gears. We hate it. We don't like one thing pushing the other and all, right? Everything has to actually flow in a streamlined manner. Helicopters are that. So they have very poor safety record. And they are expensive in terms of not only the cost of the vehicle, but also the maintenance and operation. So that's the reason why they are not affordable for most parts in the world. And we are actually waiting for electric VTOLs to do the job instead. Yeah, so once you have these wings, right, they come in as planes instead of helicopters, right? So that means that you have takeoff and landing happen in wet weather and so on. So yeah, we should actually be IP rated for wet weather. The gust threshold is something that has to be tested. We have to find out like at what wind levels we can take off and so on. Yeah, that's something that has to go through a certification process. Yeah.
Yeah, I have a couple of questions. So first one was you talked about the airspace planning, all that. So as a researcher or as a faculty, I thought that these would be done by some government agency which tells you that, look, this is the route, this is how we should do. So I was not too sure why is that a problem for, why?
What if you were hired by the government? What do you do?
That I understand, but I thought that there would be some organizations who would be doing it.
They are also so we'll have to actually help them figure out what to do.
Okay. So this is more like helping the government to plan.
So
I thought it's a problem.
Think about it, right? So when you're now taking off from Chennai to Hyderabad, all right, there is an ATC that is there
Correct.
in every airport along the way, and then there is kind of like a baton passing from Chennai to Hyderabad along different airports that are there. The Chennai ATC actually gives you a waypoint navigation. He says that go take these up. You have to touch these airports as you go along, right, overhead. And from here, the baton passes to the next airport and then the next airport and all that stuff, right? And then the ATC's radars are always watching for this aircraft to come and go. What we're talking about is, this is about 1,000 kilometers. What we're talking about is 20-kilometer flights, which are just about 10 minutes, and about 50 aircraft in the space. So 5 years from now, you'll actually have about 50 to 100 aircraft that are actually crisscrossing any time of the day. That's the kind of future we are talking about, right? The ATC will just completely go bonkers. So you need to automate the ATC, but still have a manual override. So the ATC should actually be watching this fun happening where a specific flight path has been given to the pilot, and the pilot has to follow exactly that flight path, as opposed to a verbal communication, go through this route and so on, like in the set course and all that stuff. The kind of verbal path planning is not going to happen anymore, right? It's going to be very, very precise, like a rocket trajectory. And the ATC will have to be watching for any deviation. So 50, 100 aircraft are all crisscrossing the map of Hyderabad, okay? But any deviation that's going to happen will be bam, 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 like alarm.
That's great. My second quick question was, if you can go back to the slide that you showed for traffic, where Hyderabad was listed. I was just curious, what data was it built on?
Oh, you mean the survey?
Yeah.
Okay.
Some graph where you showed Hyderabad is also listed.
Yeah, you're
Chennai was not.
So we are actually asking these questions, right? How accessible do you want this aircraft to be? Do you want it to actually? This is a survey we are asking people, right? So these are key questions we are asking. Do you want and near you, or should it land near a central point? Should it be human piloted, remotely piloted, or autonomous? Should it be a personal taxi, or is it okay to actually have a shared taxi? Should it be a two-seater, or a five-seater, or a seven-seater? Different people in different cities have actually answered differently, right? And then the aggregate of this is actually given here. Yeah. Sorry. Sure.
Talk to Professor Satya while we have our refreshments. Please.
Thank you.
Department of Computer Science and Engineering and the Mindtree Faculty Fellow at the Indian Institute for Data Science and Artificial Intelligence at IIT Madras.
Uh, yeah, so can people still hear me? And it's like really, can somebody give me a thumbs up? Give me a thumbs up if you can hear me.
We can get your slide, introduction slide, but are you changing the slides now?
No, I've not started talking.
Okay, we
I'm
can
just,
see your
just checking again if
we can see
you can hear me and you can see my slide.
I
Perfect.
can see your
Thanks.
slide,
Thank
but we are missing your video, your picture. But that's okay.
I just turned it off, but anyway,
Yeah,
now can you
yeah.
see it?
Yeah, now we can see.
Now can you see my name?
Okay.
Perfect.
Okay.
Great. Now let's get going. Cool. So I'm going to talk about safe and explainable RL. So this is the kind of outline. So a quick motivation and a couple of recent works that we did on safe reinforcement learning and some initial foray into explainability of RL policies that we tried, and then I'll conclude. So why do we worry about safety and explainability and so on and so forth? One of the biggest challenges with getting reinforcement learning systems to work in practice is that there is a high cost exploration and so on and so forth. And so what we really want is if we can get the system to adhere to certain constraints, right? So preventing harmful outcomes, right? And so that is some one thing that would be great to enforce. And likewise, if you are able to provide simpler descriptions of the policies that are learned or more intuitive explanations of policies that are learned, that helps build trust in the system because we are able to understand the rationale behind decision making. So apart from the inherent advantages of having a safe system and an explainable system, there could also be legal and ethical compliance requirements. And so any regulatory requirements will typically require us to have a safe and explainable system. And also this will ensure that we build towards responsible AI deployment. So given the the focus on AI safety and other things nowadays, right? This kind of work gets all the more important that we start looking at it. So just to give a quick plug, so we have this Center for Responsible AI now at IITM, which we have even, PK has been collaborating with us quite a bit. And so we have been looking at these issues across the board, right? In terms of not just in reinforcement learning, but also looking at other, as they call it, highly capable or advanced AI models. So going on. So the first piece I'm going to talk about is the work of one of my PhD students, Rituraj, along with one of my former PhD students, Anirban, who is currently with Google. So it's a GAN MPC, and of course a colleague of mine, Nirav Bhatt. So the idea is we are going to look at combining classical controller design ideas such as model predictive control, right? Where you can explicitly include constraints that a policy should satisfy, right? So that safety comes in built in that sense. And then trying to see how you can use that to bootstrap learning complex processes. So that is the first piece, right? So, and this goes back to one notion of safety where these constraints that you want the model to satisfy, like maybe joint constraints in robots or velocity constraints in moving systems and so on and so forth, can be explicitly written down and incorporated into the solution mechanism. So this is one kind of notion of safety that we're looking at. And the other notion of safety that we will get to in the second part of the talk is, when you have a quote unquote expert or an oracle that is available to you, that at any state can tell you what is safe. So that is basically the second notion of safety that we look at. Because safety is kind of, we it's always been a tricky proposition defining what is safety in reinforcement learning, because the very nature of reinforcement learning is you don't know if something is safe or not unless you try it. That's the whole trial and error piece. That's part of RL. And so what we are trying to do in these kinds of works is to go beyond the typical RL framing to look at how we can accommodate notions of safety. So this is one. This is a couple of notions that we're going to look at. So this is now literally switching to the set of slides from the GAN MPC work. So the question now we want to ask is, can we build a robot motion planner that is safe and can be trained with a small amount of data, because we already have maybe a base policy. And the idea here is that we would like to do this from what we would call as a non-identical demonstrator. So I'll tell you a little bit about where we came from. We started working on this problem. Of course, we did solve the actual problem that we set out to solve, but just to give you the motivation as to what we were looking at. So there is this, the idea here was to build a system, say like a mobile phone app that can use all the sensors and the camera and other things on the phone in order to plan a path in a cluttered room for somebody who is visually challenged. Right, that is where the non-identical part comes in, right? So you have a lot more sensors that you can actually get more information, but the person who is going to actually learn from your policy or who's going to execute the policy, right, is going to have much restricted sensory access to the domain, and so you have to plan or you have to learn a policy that is safe for the person to execute. So we kind of formulated this as a transfer learning problem in some sense, where you have a much more capable agent that is learning the initial policy, and then that is guiding the less capable agent to do a safe execution of the policy. So that's where the motivation came from. That is where the non-identical demonstrations and things like that came. But we didn't quite go the full length, and so we ended up doing something much simpler, as you will see when we go on. Right? But that was the motivation from which so the idea here, so for the safe part, we use model predictive control with the safety and kinodynamic constraints. Sorry, apologies. And then the small amount of data was something where we tried to learn a terminal cost model, and we'll talk about that. And from non-identical demonstrators, so we try to address that using kind of distribution matching with the GAN. So we're not claiming that these are all the only ways to answer these problems, but this is a kind of the final solution that we construct. I hope people are aware of what MPC is, because I'm not going to give a primer on MPC. But very quickly, so MPC essentially is a closed loop controller, right? It's a way of designing a closed loop controller, right? Where at every step, right, you solve the optimization problem that's given. You solve the optimization problem that is given here. So this is going to give you a sequence of actions. So basically, the idea here is to find a sequence of actions that minimizes the overall cost that you accrue through the execution, plus some kind of a terminal cost that that basically tells you what is the quality of the final state you reach and so on. So then, after you solve this problem, you basically execute the first action, and then look at what the transition gives you, and then again solve another problem, right? And then keep going, right? So you execute only the first action. It's kind of like pushing the horizon farther and farther. You plan for a horizon of h, right? And then you execute just the first action, and then go back and plan for the next horizon of h. So this way, this allows you to push the horizon back. I mean, there are multiple variations of how you can formulate the MPC problem. This is one receding horizon variation. And so this objective function can be fairly challenging to define, right? But other constraints are important. Right? So you have ST plus 1 is given by the transition function, so that you are actually solving the control problem of interest. And then you have a set of constraints. And these G and H can be used to handle any safety and environmental constraints that we want to satisfy. This is apart from what we have. So going back to these two terms here, and so in these terms, the parameters, so as I said earlier, right, so defining the full objective function is a challenging task, right? So typically what happens in this learning MPC approaches, so this we are building on top of a learning MPC paper from a group at Google. Right? So the idea here is to use a cost term, right, for the terminal cost function, which is the one that is going to capture all the future costs that you could potentially accrue. Learn that in some kind of a parameterized form, as well as learn the transition function, right, also from the data that you get from certain small number of expert demonstrations in solving the problem. So this allows you to build the components of the MPC that you can then solve it right afterwards. And I already talked about the constraint. So the biggest challenge in this MPC, learnable MPC setting that the Google guys had was that the expert and the imitator or should be identical in terms of their capabilities, the state and action representations, as well as the transition dynamics, so that you can directly learn those components. And like I mentioned earlier, what we are interested in is having an expert, right, which has a different set of parameters than the imitator, right? So we can call them the teacher and the student. I want a teacher that's potentially more capable than the student who is less capable, and I would like to see how we can. And so what we want to do is learn from this non-identical demonstrations. So the approach that we take, since we cannot match actions anymore, because the actions are very different. So that's the assumption that we are making. Actions could potentially be very different. And the behavior could also, but the transition dynamics could also be very different. So what we want to do is we want to imitate only the behavior, the outcome of the demonstrator's actions. Basically, the idea is that the imitator should try and visit the same sequence of states as the demonstrator or the teacher, right, as opposed to trying to match the policies. Right? So the way we do it is to set up a GAN that allows us to compare the state trajectories of the student with that of the teacher, and nudge it towards matching the two distributions. Right? So the way we set it up is as follows. So we have the MPC policy, right, that is learned from by starting with some random cost function for the terminal cost, and then slowly learning the cost function through the GAN error. And then this policy that is learned by solving the MPC that we showed earlier, right, that is then used to generate a trajectory in the real world. Right, and this trajectory is then compared to the demonstrator's trajectory, that's the teacher's trajectory through the discriminator, and that ends up giving me an error to train the cost function, right? And also so MK updates, I also go back and modify the dynamics model of that is used by the MPC, right? By looking at the interaction that I have gathered so far from them. So this is basically the setup. So this MPC is refining the policy every step by changing the cost function by the GAN feedback. And every update, it's also modifying the dynamics of the model based on the data gathered from interacting with the environment. So this is the setup, and essentially we have a little bit more analysis in the paper that shows that all of this is important and things will work out. And then we kind of validated it on a variety of control environments, right? So this is basically the setup. So we looked at 3 different domains. One was the cart pole, and then the kind of the pendulum task, and then the half cheat. So in the cart pole, we start with with a specific pole mass and a cart mass and cart dimension. And so we have something. You can just call these as one unit for the teacher, right, or the demonstrator. the student, we looked at various kinds of non-identical student, one where the pole mass was increased, other one where the pole mass and the cart mass was increased, and the other one where the cart dimension also was increased. So various combinations like that for the pendulum. The only thing we could play around with was the pole mass. We could have tried to increase the pole length, but we ended up doing this with only the pole mass. And the cheetah was the one where we came close to what we set out to do. So we learned on a fully capable cheetah, and then the student was a cheetah with either the front ankle broken or whether the back ankle broken, and also the mass of the torso was increased to different levels from what the learner was. Right? So these are the various kinds of ways we made the learner non-identical from the demonstration. So here is the pendulum swing of task, and you can see the expert demonstration was able to achieve the swing up very quickly. But this is with a 3-time pole mass, which would have taken a much longer time to learn if it didn't have the expert demonstration to imitate from. Right? So that's basically what we are showing. So P1 means it's an identical system, and P2, P3, and P4 are larger and larger pole masses. Right, and we can see that in all the cases, the some form of the GAN MPC does better or as well as the other. So the basic behavior of cloning, where we just try to start from the expert demonstration and try to imitate that, does rather poor. So we need to have different versions of it. So one where we try to just match the states, other where we try to match the state action, and then the full MPC version. So you can see that. It's for the pendulum. This is again for the cart pole, and here is a video of the expert demonstration. And this is the imitator, which is the pole mass is twice the thing, and the cart mass also is twice, and the cart dimension is also larger. And you can see that it's still when you just learn rather quickly. And you can see here the same thing. And with the half cheetah. So watching it learn is actually pretty brutal when you have the ankles broken. But again, you can see with the GAN MPC, with the front ankle and the back ankle broken, and with increasing torso mass, you can still see the GAN MPC does way better than competing methods. And here is an example of where even with the back ankle broken, you can see it doesn't have full control over the back legs. But it still manages to learn a reasonable gait and runs forward. And while learning from scratch, it's not able to learn even after a long time. So it really needs the expert demonstration when it is able to. Okay. So so we basically used a small number of expert trajectories, only 50 expert trajectories, and just about 10,000 environment interactions within which we quantitate the behavior of the expert. And we certainly are able to improve the sample complexity when we use the MPC. And we are also able to manage safety constraints by explicitly adding them to the MPC formulation. So before I move to the next piece, if there are any questions, can I stop and ask you?
You can go ahead. I can next. We can consider the questions later. Huh? Okay. Okay.
Yeah, I mean, the three pieces I'm talking about are completely independent. So I thought I would just stop and ask the questions. Well, they can continue. I have no problem.
Yeah. So as of now, there are no. Yeah. One question.
So this may be of theoretical interest to some of us. So do you also show or illustrate theorems that give properties that your algorithm converges?
This is too hard to analyze and give performance guarantees. So no.
Okay, thanks.
Because we throw in a GAN in between, right? So God knows what it is going to come up with, but yeah. So yeah. So we don't have theoretical analysis at this point.
Yeah, you can go ahead.
But
with
if
yeah.
Okay, I'll go. Sure. So the next piece is to talk about guided offline reinforcement learning. So quickly, people who don't know this, so offline RL, so RL typically talks about interacting with the world and learning from things. But then there are many domains where we have a lot of data that is available from these interactions, right? And so what we really want is to see what we can do from this data set of interactions that we have. Past interaction has been given to you. And the idea now is to see if we can iterate with this past data and try to come up with better policies. Right? So the idea, just quickly, some notation. So there is some kind of a quote unquote behavior policy, right, through which you have interacted with the environment. So note that this need not be a single policy, it could be a mixture of different policies. Typically, the offline RL data sets that you get talk about mixing certain expert policies and non-expert policy interactions and gathering data from all of that. And then that goes into some kind of a buffer, and from the buffer, you basically go through some kind of a iterative process from which you learn this policy. You got a quote unquote better policy. So the idea here is that so with offline RL, one of the biggest challenges is to have sufficient coverage of the state space. So and that some kind of covariate shift might happen, and so typically what people do in the offline RL setting is try to avoid learning policies that take you to parts of the state space where you have less data. Because the lesser the data you have, the less certain you are about the policy that you're learning in that space. So people try to learn policies that are quote unquote safe by essentially avoiding going to parts of the state space for which you don't have enough data. But that's not always always a good thing to do, because you're unnecessarily possibly hobbling the agent. So one of the things that we set out to do was the following. Let's assume that you have, I already spoke about it. So let's assume that you have a safety expert, right? Some kind of an oracle, which could be a pre-trained policy, or could be a human expert who is telling you, what is the safe action to do in a particular state. So this safety expert or safety oracle need not give you something that is optimal. But what we know for sure is that it's by definition safe. I'm not even defining what safe is, but it is definition safe. And so, and wherever you are not sure about the data, right, you can potentially query the safety expert. Right now, the goal is to see if you can learn a policy that is safe in the sense that it doesn't do actions that the safety expert wouldn't recommend in a particular state, and at the same time achieves a good performance. Right? So that's basically the idea. So you have the offline data, right? So wherever the offline data supports you learning a policy, you would like to use the offline data, and wherever the offline data is not, well represented, right? So then you can basically switch to using the safety expert. And how do you do this and all that? We are trying to see if we can let that, if we can learn that, right? So the idea here is to modify a traditional TD3, which is an offline RL algorithm, and behavior cloning, and look at it this way. Say, normally the target that you would want your Q function to achieve is the immediate reward plus gamma times Q of the next state action parameter. So what we do here is basically add an uncertainty term to this. Right? So what I'm doing here is like having something called the confidence. So the confidence is something that's learned offline, right? First learned a priori, and it's a fixed function that tells me how confident I am about the state based on the data that is given to me. So if I am 100% confident about the state, then this correction term goes away, and I do whatever is the original agent. And if I'm not very confident about the state, right? If I'm absolutely not confident about the state, and basically I'm going to query the safety expert, right? So this pi-e is the action given by the safety expert, and I'm going to query the safety expert. And if this action that for which I'm estimating the Q value, if it is very far away from the safety expert in some well-defined sense, then I'm going to discount the Q value. Basically, whatever. So that's So if I fall too far away, then I'll have a larger discount for Q value. So that's basically the way we set it. So yeah, in our experiments, we actually used standard policy learned with the step penalty for unsafe states, right? As some kind of extrinsic, some kind of a pseudo reward that identifies unsafe states, and using that we have learned this policy, right? And like I already said, the confidence is an uncertainty measure based on the density of states, and it is learned once. And because we were now talking about operating in continuous states and actions, we had to come up with some kind of a fancy hashing technique for assigning the confidence score based on a similar set of states occurring more frequently. And that is for the this was for the critic, right? And for the actor, we went ahead and used the standard behavior cloning TD3 behavior cloning objective, where we trade off the Q with the distance from the actual action that's taking. Right? So pi of s is the current is the policy that we would like to get to, and A is the action that is there in the data. This is standard behavior cloning. So the farther away you are from the actual action data, the more your is. So this is nothing fancy. This is standard thing, right? So this is a very simple setup. And so we have some analysis in the paper, but not a proof that we are any better. And we end up then showing things in the various safety domains, as many of the safe people, safe RL guys talk about, right? So all of these are offline RL data sets, right? So that we didn't create any new data sets. So the idea here is there are two different statistics that are plotted here. On the left, you see the fraction of actions that were unsafe in some sense. And so basically, so this is what I was telling you, right? So there is the random data sets, and then the medium experts, right? And then you have so H stands for Hopper and W stands for the Walker experiments. So R means all the data comes from a random behavior in the data set. M means it comes from a medium expert, and then MR is medium expert with replay, and M means medium plus expert, right? So expert trajectory. So these are all the kinds of setting that we have. So this is what I meant by saying that my offline data could come from a mix of different policies. So in this case, there's a random policy, there is a medium capability policy, and then there's an expert policy. Then we can see that when I run TD3 plus behavior cloning, I achieve a certain level of performance. And same with the guided TD3, which is the safety thing, the performance doesn't suffer a whole lot. You can see in many cases, the performance is actually even better. Right? But then the number of safe, so the negatives, right? If the more negative you are, then the fewer the number of unsafe actions that you do, right? In this particular case, both Hopper and Walker, how many falls do you do? So the percentage of falls, and you can see that with the safety expert, right? So we do a lot fewer falls. Not too surprising. And the nice thing about it is the cost for implementing this is minimal, assuming that you have a pass for generating the safety expert. Suppose there's a human expert available, then it's certainly not less. And similarly, you can see same behavior for the safety geo settings. And so we get. So the conclusion is we get comparable or better performance on Joe quotas and safety gym while minimizing unsafe incidents. And so, like I said, this was more of initial experimentation in order to see how we can encourage the use of different notions of what safety is than what is traditionally used in offline art, and how we can integrate it that And again, preempting the theory question, we don't have a very strong theory there. We have some analysis on that, but we don't have a strong
One
theory.
question here, Ravindran.
Yeah, Praveen, go.
Yeah, one question before you move on to the next part.
Yeah.
So, is there anything about that that section that needs it to be offline, or is it simply the fact that you have a complete data set offline, therefore you call it offline RL?
Yeah, so it is, well, see, if it is not offline RL, right? So the whole guided RL framework that we have, right, kind of falls through because we need that confidence metric, which we are estimating by looking at how well represented a particular status in the data set. Right?
Okay.
So if you're going to have an online setting, then the confidence measure would have to be something very different. Right? And then there are other Bayesian setups also that people use with online, pure online RL setup. So with the online RL setup, this has been explored. This kind of having safety constraints based on the number of times you have visited or number of times you have sampled the data. And one way of fixing it would be to have some kind of an exploration bonus that allows you to visit the underrepresented part of the state. Because we are in the offline setting, all of those things were not quite possible. Right? So we really have no real interaction with the environment anywhere. All of this is learned through offline data plus queries to the expert, which again doesn't interact with the environment when it gives us the answer. So because we are limited from online interactions, we have to make do with these kinds of hacky solutions. If you have access to the online interaction, we can do that.
Okay, yeah. Thank you.
That's.
I will find out there is any more question. Any more question? Anybody wants to ask? It appears that there are no questions, so you can move forward. Thank you.
Yes, sir. So this last piece is actually something we tried on a lark, and it actually worked really well, right? So this is about the explainability piece. I will start off by saying that I don't completely agree with even the philosophy of this work, right? I'll tell you why at the end, but let me tell you what the work is before I pile on it more. Right? So the idea here is to explore using decision trees in reinforcement learning, right? So the reason for this was, typically people have been using decision trees as an interpretable mechanism. Right? There are a lot of work in the past. In fact, going back to the late 80s, early 90s, people have been talking about learning decision trees to explain neural networks, right? So we have a very complex neural network, it could be a classification problem. Is there a way to learn a decision tree that arrives at more or less the same answers as the neural network? And since the decision tree is quote unquote more interpretable, right, you can understand the decision making process better, right? So people have looked at trees as a mechanism for doing that. And so there is a history of using decision trees in RL, right? So in fact, some of the earlier works, like going back the G algorithm, right? Ask him some of the old time algorithm. Most of you probably don't. It is Leslie Kelbling's PhD thesis. Okay? So it's like crazy old stuff, right? So G algorithm actually does basically she used a decision. The right action for you to do might be go right, but then break is probably as good an action as go right because you still avoid crashing into the vehicle in front. But accelerate is certainly a bad action. Right? So all actions are not equally bad, right? So all misclassifications are not equally bad, and so we just try to take recourse to the whole idea of the fact that we have a Q function that tells us what is good, what is bad, and now basically we add a misclassification cost. So for the optimal action, the misclassification cost is 0. For any optimal action, the misclassification cost is basically the reduction in the expected feature. That's it. You can think of it like some kind of an advantage function or reverse of the advantage function. So for the optimal action, you are fine, and for anything suboptimal, you are making sure. So now, basically, if you look at it again, brake has a value of 10, turn right has a value of 5. Okay, brake was optimal. So brake has a value of 10, turn right has a value of 5, but accelerate has a value of -10. So the misclassification cost, as you can see, is 0 for the optimal, then slowly. So now if you're going to make a mistake, right, for this state, it is better to misclassify brake as turn right as opposed to misclassifying brake as turn left or accelerate. So that's basically that. And I don't know how much. Okay, I have a lot of time. I have a lot of time for questions.
Take about 5 minutes more, please.
So basically, the idea is that we do the cost-sensitive tree, and that's basically it. And that's what we said. We are basically doing cost-sensitive decision tree classification, and if there are multiple actions that you could take now, and so looking at the cost of the actions. So now we are looking at whether we are doing well. So there are multiple domains that we tried this on. There was the lunar lander and a simple 4-room navigation domain and the taxi domain, and also the highway driving domain. So the idea is just to associations. So I can see here the lunar lander. So at very small tree depths, right? I'm trying to limit it to a depth of 1 or 2, and you can see that CS Viper. The cost-sensitive Viper, right, starts doing way better than the non-cost-sensitive versions, right, at many of the depths that we are looking. And same thing with taxi version 3, and with 4 rooms, and with highway it is even better. So even at depth 1, right, you almost reach optimal performance, right, in domains where there are many equally good actions. You might want to you get significantly better performance with this kind of cost-sensitive question. So that's the basic idea. And again, showing you multiple graphs that repeat the same thing, and looking at what is happening, right? So when I'm looking at a depth 1 tree, so this is the depth 1 tree learned without any cost, right? And yeah, it looks fine. So if the feature 22 is less than 0.25, then you go faster. If it is greater than 0.25, then you go lane driving. But the problem is this policy performs very poorly. While the equally understandable policy that is on the right, where feature 16 is lesser than 0.25, go to lane right. Otherwise, go slower. Performs almost optimally, right? As you saw in the figure earlier. Right? So the idea here, what has happened on the left, right? The classical Viper basically chooses the 2 most frequently occurring actions that are there in the data set, because it's that's basically what it is trying to bring in terms of whether it is predicting the right action or not. On the other hand, the cost-sensitive Viper chooses the 2 actions that have the higher Q value when you average them across the states that fall in that leaf. So if you average the Q value across the states, right? So lane right has the highest Q value across states, and slower has the next higher value across the states. So this basically learns actions that are better on an average than actions that are more frequent or that are optimal in more states, which is what non-constant. So there are many ways in which you can improve this, obviously. And so this allows you to learn shallower trees. So that's basically the take away from that work. But there is a lot of work that needs to be done. So right now, I mean, safety and explainability have somehow need to become integral parts of how RL systems learn when you start deploying them in the real world solutions. But then we have to stop and ask, what is really an explanation for a policy? So what we have done here, literally, is like trying to learn an explanation, like an individual action we are trying to explain. So we're trying to understand this from looking at the tree and so on and so forth. But explanation for a policy needs to be more holistic. And there are many ways in which people are trying to do that. So one way is to look at not trying to explain every decision that you are taking in the policy, right? But only what are quote unquote crucial decisions. Right? Decisions where it's very important that you make it the right way. So people are looked at again trying to attach importance to certain states where there is this high variance in the value function and trying to figure out why you do one over the other and using that as explanations or other ways in which you look at crucial. The other one is to start talking about policies in some kind of hierarchical fashion. Instead of talking about policies at the most ground level, lowest level of actions, try to see if there is a higher level at which you can explain a policy. So the example I always give is when you are giving people directions, you're not going to start by telling them go left, go right. You probably give them some kind of landmarks. So first go to that tower and then take a left and then go to this building and take a right. So you explain it in that level, right? You're not going to try and explain it in lowest level of granularity. So something for explaining any kind of topics, trying to align with some domain understanding of the structure of the environment, right? Explaining that is the direction. Of course, people are now trying to talk about narratives, right? So some kind of a verbal description of your thanks to all the LLMs and other things. So talking about, can you come up with some kind of a chain of thought, quote unquote, explanations of why you arrive at certain decisions. That kind of narrative descriptions of policies or another direction people are pushing ahead. And likewise, when we're talking about safety constraints, so we talked about safety while learning, right? In this particular examples that we talked about. But you could also talk about safety while deploying. And so what does it mean? What forms will it take? Right? So, the other piece that we are trying to make headway, but still a lot of work needs to be done as a community. We're talking about human-aligned RL architectures, where there is a room for a human being to intervene or to interface with the RL agent in some way or the other. That overall ensures safety, while looking at other kinds of constraints in terms of how the RL agent communicates with the human and the cognitive load on the human and the frequency of interventions, etc., etc. So all kinds of other factors can now come into play. Things like the human-computer interaction piece, the HCI piece now becomes important when you start talking about these kinds of architectures. So I'll stop here. If you have questions.
So any questions?
So that's the new department website, and that's our new department.
So can you explain what are you doing here actually? This is the part of IR, the separate one. What is actually?
It's a department. It's a department.
Okay, department. Okay.
Just like the police. It's part of the
So how would one differentiate between a regular RL problem and a safe RL? Is it just saying that you take a regular RL problem, employ a lot of constraints, and violating constraints is extremely costly, and then because these constraints require you to deal with a regular RL problem differently, it leads to techniques, and those are called as safe RL. Because, so if you look at risk-sensitive RL, right, you're minimizing the expected returns under CVAR constraints, right? You want to minimize value at risk. Can I classify that as a safe RL problem?
So something like CVAR, looking at risk sensitivity is one form of safety, right? and so the challenge is the following, right? So suppose, so for example, I'm trying to learn some kind of a driving policy, right? So I might have constraints that says that you cannot drive beyond a certain velocity. So while if I'm trying to solve for optimizing the reward, I might occasionally go above that velocity, right? So that I optimize for it in places where I think it's fine, basically, because I'm optimizing for the reward. But then if I have a constrained RL setting, right? So where I'm talking about safety, where the safety constraint is imposed from outside. So that is one way of defining safety. And there are other notions where people have talked about safety, where it's kind of like a more strongly controlled idea, like Lyapunov constrained learning and things like that. So where you are always constrained to follow some kind of energy surface, which you know will eventually lead to reduction in energy, right? And not necessarily go up the energy at any point, right? Even though there might be safe paths for you to go up the energy and then minimize later. But so all these kind of Lyapunov constraints will always force you to go down some kind of energy surface. So there are different notions that both in control theory and in decision making, like OR, where people have talked about constraints and safety. And in fact, there's one notion of safety that we worked on, which is to do with jitter. Right? So when you're trying to learn control policies, you don't want it to vary too high. So the constraint was on the second order rate of change, right? So there are very rich literature on looking at this in other domains, and we are trying to see how we can translate that to R.
Right, and would it also be possible to consider problems where the constraint itself is not known? And you want to learn these constraints where, like what happens in, suppose, Bayesian optimization, right? You could have Bayesian optimization with some constraint, and the constraint may not be known. You don't know the box for your optimization problem. You violate the constraint, you see a huge penalty, and then you also figure out the constraints.
Yeah, that gets closer and closer to classical RL. So we'll have to figure out, what is the, so if there is a separate generalizer that talks about the constraint, yeah, sure, we could talk about that. Learning, we can learn constraints that way. But if the way you're framing it, the feedback is still coming from huge negative rewards, right? So that's becoming more like classical RL setting. But if you have some other structure that you impose on the problem, then that could also be a safe, consider one of a version of safe RL.
Okay, thank you. I think there are no more doubts. So thank you, Rabindran. My name is Krishna Reddy. I hope you know me.
Oh, come on, sir. I know you.
Okay. Okay, thank you. Actually, this is a very deep talk and it's very informative talk. And your last slide is very good, actually. So,
this one or the one before?
No, the one before.
Sorry.
The one before. Okay. Okay,
Sure,
thanks once again for interesting talk, and I think for the next program.
Any more questions? No more questions? Okay. Thank you so much, Professor Ravindran. We met last month, if you remember.
Yes. Yeah.
Okay, thanks a lot. So no more questions. So we will close our second keynote now. Thank you so much.
Thanks, folks. Take care.
Yeah, we would have given you a memento, but then we can't do it virtually. We'll try to do something about that.
But next time I come.
Yes, next time. Yes. Thank you so much. Let's start. I'll call the panel. Okay. So we come to our last event. This is a very interesting panel discussion. So let me call the panelists who are already here onto stage. So Dr. Kiran, Ms. Reena Dayal, Dr. Parmeshwari, our very own Ramesh Loknathan will be the moderator. We are just waiting for the fourth panelist. He's in the elevator. So I will allow Ramesh to introduce the panel and the panelists. Please come onto the stage. I'll get Pradeep.
Yeah, she's coming. This is a startup. It's a drone startup. So good evening. Thank you, Param, Kiran, Reena, and Pradeep in absentia. So this is, I think, given that Kohli Center is, the idea is to not just frontline research, but also applied research that could mean something for society is a part of the objective. So I think Sunimi has picked this topic on how do you create not just deploy systems, deployable, repeatable, scalable kind of systems out of all the research work, right? Which is never easy. I always say research is hard, translation is much harder, right? And because researchers have to do translation and there's a fundamental DNA mismatch. Please, Pradeep, come, join us. Yes. How are you? Good. So please come. So I think we have a fantastic perspective here on the panel. Dr. Parmeshwari is a faculty here in our Language Technology Research Center, and she works on computational linguistics. And I hear a lot of Tamil these days in our lab. I sit right next to Param, so I hear a lot of Tamil because she's doing some work on Tamil language. So, and then we have Kiran. Kiran is a well-known name in our campus. There are professors that collaborate with him. He's a well-known name in the 5G world, in the communications world broadly, specifically in the 5G world, extremely well-known. So Kiran, thank you for coming us. Professor Kiran Kuchi from IT Hyderabad. Reena Dayal, again, very, very active, was in industry for a long time, Microsoft for some time, and did many things. And now last at least 5 years has been focused on quantum. Started with doing some work inside Microsoft, and then I was come out and started a very nice quantum think tank and a group. She's very, very well connected in the quantum world in the country now. Probably every research lab, she knows people. And every company that's doing quantum also, she knows people, right? Not just she knows them, she knows people in those companies. So we're very happy that Reena is also engaged with us quite actively. And Pradeep is a startup that started in CIE, in our incubator, and one of the early adventurous ones, bold ones to venture into the drone space in agri space, right? It's a grassroots problem. Like agri is not easy because you have to go one farmer at a time to bring value. And he's been very, very patiently persevering in that space. So that's a perspective that Pradeep Paleli brings with his Thanos drone startup in the agri space. So I would request each of you, just quick in a few minutes, introduce your background, your work and your background as the context for our discussion. Param?
Am I audible? Yeah. So I'm Parmeshwari, working in the field of computational linguistics, which is popularly known as natural language processing, a subfield of computer science and linguistics. So we work in building core technology tools and applications for languages, especially Indian languages, and very specifically low resource languages, because that's where we have to get in, because a lot of technology and applications are already available for very many languages, but the low resource languages are still suffering. And India being a multilingual country with a lot of languages spoken everywhere, you know that not only 22 scheduled languages, there are many more languages which are spoken in the corners of India. So our aim of research is to build applications and technologies for those low resource languages to make sure that there is equitable representation and utilities of these technology that we are going to deploy in the realm of AI and NLP. And having said that, I come from computational linguistics. Our team is also exploring the potential of LLMs and looking at the linguistic inquiries of these LLMs, how it can be leveraged for different tasks, especially in the context of Indian languages and India. So that's the major research I'm doing. Hopefully, I don't know how I fit into this whole thing, but I'll try to make little sense.
The whole, given that ChatGPT and OpenAI made LLMs a mainstream social name, what you're doing is extremely relevant in that context. Kiran? You can take it.
Yeah, it's okay. So my fun activity is to take my ChatGPT and speak to it in Telugu and ask it to speak me back in Telugu. It does fairly well. And I did do this with actually a lot of different accents, different regions. I challenge it. And I ask one Telugu guy, one Kannada, one Tamil, and one English with different accents. And we all take at the same time and ask it to respond back. So this is my fun exercise. Okay, you have a lot of hard work to do. Okay, thank you. So exciting things on natural language processing. So I have been working on developing wireless communication systems, popularly known as 5G. I have been doing this for a number of years. I joined IIT Hyderabad in 2011. We used to be in the ordnance factory. We had a shack. That's where we started building all our systems and training people. We came a long way. As of today, we deployed a 5G network. All components are engineered and designed, and there's a network operating in IT campus in Sangareddy, Kandi. We are going to take this to a large-scale commercial deployment soon. So other than this, I work with the government fairly closely, driving the ecosystem in this space, both domestically and internationally. Thank you.
It's a very bold endeavor to build the networks, right? Even government hasn't been that ambitious. They're saying let's adopt network. So all their 5G use cases lab and all the work they're doing is to make sure we are early adopters. But good that you've broken that barrier and you're actually building the network. I think it's time we did this. Hopefully 6G we will do even more as a country. Reena, you're...
Yeah, so I think you did a pretty good introduction. I'd just like to add that right now in QETCI, which is the name of the entity, one salient fact is that the address is IIIT Hyderabad.
Thank you for that.
The second thing is that our mission is to enable and accelerate the quantum ecosystem in India. We genuinely want to make sure that we act as a catalyst agency who works very closely with the government, industry, academia, startups, investors, everybody, so that India can be on the map of quantum and we don't miss the bus, as it is called. When people talk about semiconductor, we say we missed the first bus. So we want to catch the first bus in quantum for India. So that is what I'm doing right now. My background is mostly deep tech. Started my journey by working on networking protocols and operating system, and have been in the specialist. I did not go along that route of I need 1,000 people, 10,000 people in my team. I chose the specialization route. So that's the difference which allowed me to be doing what I'm doing right now.
I think we need that. We need a lot of this. And in the semiconductor world, I don't think we missed the first bus. We also missed the last bus. So hopefully we'll be different in the quantum world. Pradeep?
Hi everyone, thanks Ramesh for the introduction. Certainly our association with IIIT goes a long way. Like Ramesh rightly said, we were first incubated here from 2018 to 2021 onwards. I still remember the cabin names in which we were there, C5112 and C5108. One was a 4-seater and then we upgraded to a 8-seater after that. Now, 4 or 5 years later, we have come a long way where shortly in the next 2 weeks, we'll be shifting to a 10,000 SFT manufacturing space in GD Mitra with a production capacity of 200 to 250 drones per month. That's where we are right now in terms of scale. And the focus area for us is agriculture. I may not fit in terms of knowledge with the others, wherein there's a lot of intelligence that comes in on the natural language processing and other AI/ML solutions. Given that we are primarily addressing the automation issue, or what application area we are focusing on in terms of automating the manual activities. Certainly, the intelligence does come into the picture. We are just in the early days of that, you could say, where we are trying to club both agri-automation and agri-intelligence. The two parts under which any application that has to do with agriculture when it comes to drones falls under these two brackets. So far we've been focusing on agri-automation part, automating all the manual activities like spraying of chemicals and all. Now we are bringing the intelligence aspects, be it visual and other sensor payloads, and we're trying to make it more intelligent and close the loop around precision agriculture. That's where we are right now. And certainly I can say that every time we are in IIIT, there's quite a few things we've learned. And today, in the first 5 minutes, I've already learned one fact, that you can speak to ChatGPT in Telugu and get an answer back as well. So far, I've been thinking it's only English. I wasn't even aware that there were local language support and all. Certainly, I can say I can go back today with a lot more knowledge than I've come in today due to this panel discussion. Thank you.
Thanks. Yeah, I'm sure it can't design and build drones yet. So So we'll just take a few points and then let the conversation free flow. So Kiran, I mean, like the whole 5G experience, right? I mean, like as much as you are a core academician, core researcher, you also chose an area where, like you rightly said some time back, that you got a full 5G network already running, built ground up, right? And ready to deploy also commercially. And and especially communications, I think the demands on performance and robustness, stability is much higher. Yes, it's not a banking system where you may lose money, but that said, tolerance for, I mean, when you pick up the phone, you want to be able to dial. It can't be down for probably like even a few seconds. So what are your experiences designing for that, right? As you build this network ground up, what are the experiences in terms of making it deployable, like you said, ready to scale now, making it deployable and making it robust? What were your experiences and how did you address that?
Yeah, so every day we measure our uptime of our system, because the first system went outdoors maybe 3 weeks ago. So we are really at an early stage when I went outdoors.
Outdoors meaning outside of the campus?
Yeah, just like you take a phone and you can connect.
Connect to it.
Yeah, we have Jio and Airtel in the same area, and we use BSNL frequency. So it's a one tower with a couple of sites. So we test it around that area. So we have to measure the uptime in terms of number of days the system runs without reboot. So we are at 2-3 days now. Continuously the system is up and running, but that's nowhere good enough. The system has to run for months, days, and so on and so forth. These systems are running all the time. So the software stability, and it's a very complex system. There is a radio, there connects by fiber to something called a baseband unit, and then there is a core network. Of course, it's a distributed system. And if something goes down, you have to bring it back not in minutes, but just a matter of seconds. So this requires, these are all things that have to be factored in from early stage. So our engineers are really busy. These are the guys who used to do matrix inversions, writing C code in their early days, and now they have to do this. So the transition is really quite a bit. I mean, somebody who studied probability random process, DSP, doing homework assignments, they don't think about building a network that runs for years.
You send something, it transforms, gives it out, the job is done.
Yeah, so we have people that have grown along the way, and we are making it happen. So next stage is to run a network of 50, 60 cell sites over a large area. There is a place in Ambala we're trying to get there. BSNL has a test facility, and they test this, over months and sometimes several months. And once you qualify, then you're allowed to scale up. So it's a long, hard journey. So.
And it's truly amazing. How are you managing it? Just a follow-on question to that, right? Yeah, you told, I mean, the ones you're referring to, I'm assuming, are all research students, right? So how are you supplementing? You need that level of understanding anyway, right? This is an emerging system, and as a country, we haven't done this as much, so you can't find ready experience also. So you need the research, cutting-edge team and knowledge and research coming to play. But how are you supplementing it when it comes to engineering and the robustness and reliability side? Did you get some help from outside? Or how are you supplementing that aspect of knowledge into this whole process?
Yeah, so first of all, this is run in a company that we incubated.
So you do have engineers also?
No, this is not a student project.
I understand, I know that.
So I mean, that we recruited students, some bright ones years ago. But for the last 7 years, we are running it this through a company. We got grants and funding to do this project. So there are professionals who do this. They do this for a living. And skills, they are not just in one place, right? You can't say that I will learn all these skills and do it. It will take 100 years. We work with the partners all over the world. You have to pick and choose the best of the practices, elements, stacks, whatever it is. It's an immense, even take Ericsson, for example. If you examine their system, probably 70% is not, the chips are not designed by them. So they probably do a systems integration and engineering. So it's kind of like that. So you have to put together a lot of different things. You have to put your own software algorithms in it. Yeah, we're managing to do it. Yeah.
So good. I mean, so I think one key aspect which I knew, but good you highlighted is that this is a startup now. While the work started off as academic research work, it is a startup. It's almost 6 years now, right? 5 or 6 years. And it is a long gestation space that you are in, right?
This is,
so good that it's been supported so long through all kinds of
and
means.
Just remember that this whole indigenization, when we say indigenization, some people think that you take the bread, you make it, you take the atta, you make it, you create a pizza on your own, all ingredients are grown in your backyard. It doesn't work like that.
It doesn't,
this is a global activity, and
Yes.
we have to be working with all the stakeholders day in, day out. So it is indigenous, but it's global at the same time.
True. I mean, the subsystems come, you pick the best of whatever is available and then put the whole solution together.
It's kind of like that, yeah.
No, amazing. Nice to see that happening, and we really want to see this getting deployed. So good that you're looking at the first deployment in Ambala. Hopefully that's very successful and then starts becoming, it's nice to get to see our own homegrown networks deployed and used. So all the best with that. So just on similar lines, Param, talking about the whole language space, right? Now, it is, we know, I mean, like we've been an nodal institution for the language technologies mission, MITES, for many, many years, along with many others. And I've heard this from MIT itself, because I'm also on some of their committees, and I keep joining those meetings, that they just keep kind of bemoaning the fact that so much work has happened, so many PhDs, so many papers, so many conferences, in thousands probably, if not hundreds, definitely in hundreds and maybe even in thousands, because these are 10 top institutions in the country.
And LTRC produces. Already LTRC produced so much of research.
We are one of those 10. So now, and then they say zero solutions, right? Until a few years back. And now in this new avatar, Bhashini, right? And now there's a much stronger solution focus. And still they seem to be struggling, right? Because from whatever I hear from Prakash and others. Now, why is it so hard to get, while we are creating knowledge, we have the understanding, and the knowledge we are creating is getting published as a country, whatever happens in these 10, 15, 20 institutions, gets published along with the best in the world. So it's not like our knowledge or understanding is any less than the best. And still, the solutions are elusive. What is your view on that? I know you're not in the solution space entirely, but you're also there, right, trying to do things. What's your view? Why is language technology solutions so hard to bring it out?
Yes, yeah. Well, this is like a $1 million question, because everyone expects LLM or any other AI which thinks like a human being, generates the language like a human being. Our human cognition is totally at a different part, whether we have reached to the position where the machine mimics the human mind or not. It's still a kind of research. And thanks to Professor Kiran kind of researchers, we are trying to kind of connect it with a lot of people. But now the connection that we need is whether we are connected locally, right? Because most of the research happen in English. Most of the tools that are being developed, applications that are available for usage are mostly in a very highly resourced languages. Right? Even then, LLM produces a lot of hallucination. We cannot accept or believe some of the output that it produces. Like, as long as language is concerned, research is concerned, a lot of research have been happening, but why we are unable to get into the mainstream and use it for the real time? Of course, there are many issues. One is because language is incredibly diverse. We do have too many languages in India, not only in India, in the world, we have thousands of languages. And when it comes to the culture, again, language is a gateway of most of our culture, right? Languages expresses those cultural information in a totally different way, a lot of differences in the grammar, vocabulary, and the structure, and so on, right? So, and again, not two human beings generate the language in the similar way. We have a lot of diversity among ourselves. So now we are expecting one machine generates the language which is on par with the human cognition is really, really difficult thing. And to make it use in the real time, there is a threshold. We can use it for a particular purpose. We can, like for example, machine translation. You can extract the information from one text to another text. You can use question answering kind of system in a particular domain. But if you want to use it in a very general domain, there is a problem. Even now, most of the applications that we build, it's not adapted to a particular domain. It may work for a particular domain, but if you change the domain, let's say agriculture to health, there is a huge difference because the domain terms that we use are totally different, and the kind of polysemous words that are there in one domain, like no, it keeps changing. Though the important thing is we should understand the ambiguity that are there in languages. Whether we are able to capture all the ambiguity or not, it's still a problem, though LLMs and other neural networks are trying to do it. A lot of linguistic researchers keep happening. So again, with a lot of data, languages like English, with a lot of data, we are able to build some application. When it comes to Indian languages, again, we are still in a low resource setting. Right? So when he says, if he wants to listen, LLMs uses Telugu or Tamil or Hindi, we are so happy because we want to localize, customize the tools according to our requirement. So there is a long way to go. Of course, we have reached a position, but let's not think that we have achieved it. So we have to work.
So how do we get more? See, in Kiran's case, he had the kind of the idea and the vision and the drive to go set up this company to create it. Long gestation. I'm not sure if you expected 5 years to trials when you did this, but I'm sure you expected 2-3 years at least, right? It's a long gestation, right, from the word go, but got engineers in, got the right professional experience in, partnerships in the world. See, as an academic institution, you don't have to do all that. Okay, you can demonstrate something and get your research output without doing all that, but as a commercial solution, like Kiran said, you need to get the best in the world and the best teams kind of designing and building it. I don't see as much happening in general in academic research. I'm sure even this is an exception, right? Doesn't happen so often. Why is that not happening? I feel real solutions won't happen unless you work very closely with people building the solutions. And the easiest way for an academic institution to do that is by some of the faculty or students doing it. Why do we not have enough of it? Any thoughts of actual companies that's coming out of startups?
Can you repeat the question?
Startups coming out of our research.
Yes, there are a lot.
Professors, the students are part of it. How do we get more of it?
Yes, that's very, very important because it's not like one person finding a solution for this kind of problem is not at all good. Even one machine, for example, Google Translate. One machine provides the output is not a good solution because each one of us has different way of, let's say, if I ask each one of you to translate, we translate it in totally different way. But if we are looking for one solution from one machine, it is totally difficult. So we definitely need diverse applications, diverse research in producing different kind of outputs in the NLP paradigm especially. And the reason why many of them could not get into startups and other things, one is data, right? So the complexity and diversity of data that we need to build for this kind of solution is very, very important. But whatever data, what we have, either internet or open source, there is a concern, especially in NLP research, is whether the quality of the data is good or not. So we don't have that high quality data. If you don't have high quantity data, at least we have to look for high quality data, which is not there in both the cases. So we still again look for solutions from different languages. For example, OpenAI has designed the LLM for English. You try to mimic it for the Indian language context, right? So, but that OpenAI algorithm and modeling is working for English, but think that our languages have a different diverse culture, context, as well as linguistic phenomena. So when we are trying to mimic, we try to do a lot of fine-tuning of the same kind of thing, right? But when we try to mimic it, our languages have totally different thing, right? Our technology is not yet ready for this kind of languages. So both technology-wise and data-wise, we should be ready. Only then the solution can come in the future.
Hopefully soon. Reena, you work with a lot of research institutions and industry in a very new area where we're probably not too far behind the world, right? We're behind for sure because there's some US, some of the European countries, and even China, Japan. They're probably investing a lot already in quantum. But we're not too far behind. We're a little behind, but not like in other. So what is your reading when you look at academic institutions, some of the frontline companies engaged in frontline research? Many of them are global companies with India presence, but there are Indian companies doing it as well. What's your reading? Are they doing it any different? Meaning there's a real world focus, real world solution focus from the word go, or is it not much different in this also?
So, yeah, first of all, I think you're right. We are lagging behind in certain areas. But interestingly, in quantum, there are areas where we can say we are at par. So, for example, quantum communications, we are actually doing a lot in India. And there are situations and cases where the world looks at us and says, oh, I want to know what you're doing there. So, that's a good sign. Definitely, there is. In fact, I was thinking about this when you were asking the question about this gap between actually research and solutioning. I think there is a fundamental gap in India, and that gap exists because this whole concept of translational research and solutions is relatively new in India compared to the rest of the world. And we have not still figured it out perfectly. In terms of the processes, it's more like we want solutions and now we want everybody to work on solutions as well. The reality is that when you have a mature ecosystem, you finally reach a stage where you allow the theoreticians to do just exactly that. When you look at the researchers, they are all of different kinds. Sorry, I'm speaking on behalf of the researchers, but there are people who just want to go deep. So for example, if you look at Professor Arun Pati, who's a theoretician, a theoretical physicist, he's pretty well renowned across the world. He was not somebody who would be interested in doing applied research. And that would be a waste of his talent also. But on the other hand, there are people who are working as applied research scientists in the quantum domain. And when you look at applied research, by definition, it becomes broader. Because when you do theoretical research, you go deeper into a certain area, and you could be doing theoretical for LLM as well. But when you start looking at solutioning or applied research, by default, you become a little bit of a generalist. Not a generalist like a generalist in the industry, but vis-a-vis researchers. And there have to be mechanisms for encouraging each of these domains and understanding how this fits in the ecosystem from a longer-term perspective. I think the good thing about the NQM or the National Quantum Mission is that there is recognition of this fact. And there is some learning that has come from the past missions and things like that, and that is being applied. To answer your question fully, it will take time because there is a process angle, there is ease of extending yourself. Number of startups that come out of Indian institutes is low. Now we are talking about not just translational research, we are talking about fundamentally many steps in the process which have to be added. For example, if you have developed, let's say you're developing a quantum sensor, if you do it in the lab, even if you're an applied researcher, you will set up an optical table and you will be doing experiments on that. Your sensor would look like on a table 10 times this size, it will be set up on that. Now there are multiple steps to it. You will need people who will have to reduce the size of this whole thing. Then you need people who need to test it in the field. Then you need people who will actually be able to do further optimization and miniaturization. That is an engineering job, not a scientist job. So here we are again looking at multiple steps in translation. The moment you have hardware elements, you also need to do testing of very different kind, right? So that capability development, we have misunderstood in many cases how many steps are involved and the nature of the partnerships that need to come in there. Now, I come from the networking background and, sometimes I dwell a little bit into the development. Wherever there is a little bit more regulated environment and standards are clearly specified, it is a little bit easier to drive productization. It's a very difficult task to do 5G, so I'm not referring it to that. But I'm saying in the quantum space, we are in early stages. And in LLM, there is no standardization at all. So when you look at these areas where there is no standardization, we include an additional complexity because your ocean is very vast. How do you productize? What do you productize? And you are now getting into the domain of also anticipating uses because it's a new technology, completely new technology, which requires even tighter integration between industry and academia. And unfortunately in India, that is a very weak area. So I'll stop at that.
No, absolutely. I think, like you said, probably the challenge in quantum is like even engineering, every aspect of it is new. That you only can tap into some of the experiences, but most of it has to be groomed and grown organically. So that's the challenge. So Pradeep, you had a different challenge, right? I mean, yes, technology was a challenge, but for you, a bigger challenge was like making technology work at the grassroots. It's a completely different ball game. How did you address that? How do you make emerging technology work in the grassroots, bottom of the pyramid, where the capacity to pay is not very high, right? That limits the way you go about the market. So what were your experiences building for that market and kind of successfully taking it and start to scale?
Right. So we in fact had two challenges, not just the customer point of view, but given that drones are a regulated space, our initial 3-4 years, we got caught up in the regulatory space itself, where just because a handful of people tried some really interesting to them but stupid in general applications, where someone tried to deliver a pizza in the middle of Mumbai city, and the police caught wind of that, and next day drones were banned across India. This was in 2017-18, and we had just started about a year and a half ago. So until 2021, yes, we had to grapple with the major challenge of regulations itself. So until then, we were working with our non-core application, trying to supply drones to defense applications, and we worked with research institutions, including IIIT, IITs, and others. But once the regulation space was done, so this is common to aviation and almost any new application that has the tendency to be potentially be used in a negative way as much as a positive way. But once the government also realized that banning drones in general is not a great idea, given that the rest of the world is advancing on that front, so they decided to certify the good guys and separate the good guys from the bad guys. That's why we are now on the regulatory front. So we are able to legally get our drones certified and supply in the broader market. And whenever the government gets to know that there's a drone being used for an unauthorized application, it's a simple difference that whether the drone is certified, whether the guy who's flying it has a driving license or a pilot license, as simple as that. So regulations were to some extent handled and we are able to function. But the core agri space itself, the reason we started the company and the products that are there, it's been 3 to 4 years since our drones started getting deploying and a lot of pilot projects and commercial projects happened. But on a day-to-day basis, we keep seeing this question of the pricing. No matter how advanced the drone is or how good it performs, there are always cheaper solutions in the market, and agriculture being a price-sensitive market. There are pricier solutions. You have the John Deeres of the world, and you have the other John Deere, which has even launched an autonomous tractor, in case some of you have not heard about it. It's a standard in the US, but now they've introduced it in India as well. You don't need a driver to drive the tractor anymore. There are those kind of products as well, and then there are the smaller 20 HP tractors, which cost less than 3-4 lakhs. So there is market for both, and we have something unique in terms of our product. But despite all those advantages, we still keep grappling on a day-to-day basis on the pricing front. And the way we handle it is by carrying out demonstrations and showing the value. Until we show them what it does and until we quantify. Sometimes the benefits to customers are quantifiable, sometimes they are intangible. Something as simple as, just to take the testimonial of one of our mirchi farmers in Warangal, in Dasarpalli, Narsampet Mandal, 2.5 acres of land typically takes them just half a day to get it done by a manual labor. But they end up hiring the labor for the entire day because no labor comes for just half a day, or they don't charge for half a day. And on top of that, you have to pay them, you have to feed them, pay them for toddy. If something happens to them during the spraying of harmful chemicals, you have to take them to the hospital as well to get them treated. A drone addresses all this activity in 30 minutes. 2.5 acres can be sprayed in just 30 minutes in a very autonomous and efficient manner. So there, for him, the aspect was not pricing. The labor was available at just 150 to 200 rupees per acre. But he paid us 400 rupees per acre. And his simple requirement was that I should be able to see how the work is happening transparently, because I don't know how the labor is working. So that's an intangible factor that he was keen on. And the second intangible factor is the efficiency. he could convert it into a quantifiable number later on, but he wanted to avoid the hassles of identifying labor first of all. Labor is available in some places it's not available. But identifying them, getting them to do the work on time itself is a hassle for them. So these are some intangible aspects which we didn't even understand when we got into it. We just thought, okay, there's a labor shortage, okay, there's a efficiency issue, all these are quantifiable metrics. But not every customer looks at it the same way. Every customer is unique. So we decided to take an approach where we segment customers in terms of what is their requirement, what do they value. And all this comes up only when the first set of demonstrations happen. Once the demonstration happens, so basically this, when someone is about to start a company, people keep obsessing about the product. So we keep hearing this, that focus on the customer, not the product. So that's where we understood that after quite some time, there are intangible benefits that we completely ignored, as in we weren't even aware that this also could decide whether they'll buy the product or the service. So these are some things we slowly started to address and based on which we could productize and scale even further so far.
The models itself, how did you evolve, right? Because if they're going to pay 400, 500 rupees an hour and your drone costs 5-6 lakhs, right? What are the financial models and the operating models? Because if there's a village with 10 farmers, having a drone kept there is not the best way to do it. So what are the other intangibles in terms of the models inside that you figure out to make it work?
So business model wise, I would say it is always a continuous evolution, as in even the biggest companies keep pivoting once they realize that this is not the market sentiment is. But in our case, there are 2-3 models in which we approach. Initially, the agrochemical companies with whom we worked, we thought will be our biggest customers. They turned out to be partners rather than customers. So after the first 1-2 years of trials and pilot projects that we've done, they realized that drone is not as simple as a car or a tractor. There is some sophistication, complication to it. And we are not the best people to actually own those assets or rather invest and own. So that's where the model slightly changed. So even as on it, our primary model or go-to-market is where we sell the drone. We did initially do services for the first 3-4 years, but that was primarily because the regulations did not allow us to manufacture and supply. So we provided service to popularize the technology or the concept. So that's like a way around the regulations, you could say, that you don't have to wait for them to bring in the regulations for you to supply the drones. You could actually go around it and actually popularize the technology by going into a service model, which nobody was stopping. So that's how we got into it through the agrochemical companies, but later on they realized, let's not buy it. Let's partner with these OEM companies or service providers. So as on it, our primary activity, or core strength, I would say, is manufacturing and supplying. But there is this third entity, which we call a DSP, drone service provider. Now, they are the ones who own these drones and provide the services. You could think of it as Maruti or Tata or any of these automobile companies manufacturing the automobiles, but Uber or Ola or any of these guys running the service, and then the pilots who are the license holders, who sometimes may own the drone or sometimes may lease it from the company. So these are the current active models, and that is the way we think this technology will scale up across the country, because no one company can own drones and service the entire scale of India, where we think the market size itself is 4 to 5 lakh drones required every 5 years. So it is too big for any one company to actually own and service. So there will be micro entrepreneurs on a village level, and there will be aggregators or larger service providers on a mandal and district level. And then there will be the larger companies like agri-machinery companies, which will, through their dealers, be supplying drones, also service across different territories of the country. So that's why we are partnering with all these guys, and we are trying to be the backbone in terms of the drone manufacturer, technology provider, making sure the drone time is minimal, providing proper after-sales service and availability of spare parts, so that they focus on their core job of providing service, and we make sure the drones are good.
So you have to integrate upwards, downwards, sideways,
everywhere.
Right? Educate, integrate, evolve models.
Now, training is an even bigger challenge. So that's a point I wanted to make when the other panelists were talking about. 2 things that we realized, the language part, why I was fascinated to hear that there are other regional languages as well. Even something as simple as creating brochures in local languages. given that this is no longer so this is not a urban application, what we are talking about. This is a village level application. So there are hundreds of regional languages we have, and it is becoming difficult for us to even communicate with the end user in the language. So it's not like we have 100 salespeople speaking different languages across the country. So something as simple as getting a product brochure in a regional language, which is not as simple as translating it in Google Translate. Because accent and all are a step further, but even the basic meaning. So recently when we made a product brochure, we translated from English to Kannada. And it turned out Google Translate added a little bit of Tamil in that, which we understood after printing 5,000 brochures. And
that knows Telugu, you could make out the difference.
we couldn't. So we had to hire some other guy to validate it. And then we realized that after that regional guy read that, he said, this is not what the English language says. The meaning is completely different. So there is a lot of validation that even now Google Translate doesn't do a good job in. And to add to this, the training part, given that these are used in the different parts of the country, government is mandating that you conduct the trainings in regional languages, whereas most of the training content is in English. Getting it in Hindi is also not sufficient, even though it's the official language. There are so many other regional languages we need to. So these are where we've not even scratched the surface, you could say, in terms of commercial applications. If there is no sophisticated model that can actually do a good job without me relying on an actual human to do the translation. We are still far from that.
Kiran, in your word, you already said you connected globally because you need to source knowledge and its capabilities, technologies, chips, whatever, from wherever it's happening in the world. So you partner extensively. Do you have a challenge locally in terms of building the ecosystem or building the supply chain support systems? Have you gone, have you got some experiences there already, or you're still kind of yet to get, because you have to get into the field for that? But any experiences there in kind of integrating this? Because you have a similar, as a country, we don't build this, right? We haven't built telecom equipment for a long time. We're just importing it. So many of these expertise that may be easily available in other countries, we don't have. What are your experiences with that? Because at the end of the day, to take to market, you need everything.
Yeah, so we are now getting into mass production stage of a couple of different things we do. These are high-end electronics, essentially. And we never had any skin in the game. Building systems software is the one thing, but manufacturing at scale is something else. So we discover many challenges and we solve them one by one. For example, in the base station, we have two critical components. One is called a baseband unit. It used to be a custom ASIC driven box, like a set-top box. But luckily, the technology moved to a point where you can use a server, and then we play with the mostly radio software. So the underlying chip and the comes as a server, manufactured server, like the Dell or somebody, right? There are 3-4 different server manufacturers. So we got lucked out there. So, and we have strategic partnership with the chips that go into server, Intel or AMD at the highest levels. So we solved that problem. So essentially, the communication system is running on servers. That's a big departure from the previous systems. Then there is a second critical piece. It's called a radio. It's on the top of a cell tower. You see an antenna, and then there's a little box below it. You just notice. It's called a radio. The radio typically includes power amplifiers, all kinds of electronics. Okay, lots of analog electronics, and some digital also. This part, you have to manufacture, and you have to get. We have got the designs done. We're in fact getting the designs done for those parts. But then we have to solve what is the yield of the radio. If the yield is not more than 95% the production line, the cost will go up. And we don't have enough domestic manufacturers, and they have not done this before. So there is no previous track record of building this. So I'm dealing with the empty assembly lines in ECIL and ITI, all the way to Flex, and a lot of other, Taiwanese manufacturers setting shop in India. We are working with all of them. It's a hard problem because in other countries, this is a mature process.
Exactly. You can just
so we have to solve this.
Just engage the service, which you can't. You have to create the capability here.
Yeah, so one at a time. But what helps though is that we need volumes. If we get 100,000 units of cellular base station radios on order, then I can sort of manage it and solve it, maybe not the best possible manner. And then the next phase will be easier. But if I have to supply 1,000 units or 500 units, that's going to be hard. So manufacturing of high-end electronics, critical components at volumes is just not there. So this is a challenge, but we have to find ways to solve it. This applies not only to the base station radio equipment. We also found this peculiarity. There is one chip that we developed. I didn't talk about it early on. It's a chip kind of like the one that goes into smartphones, but it's meant to connect sensors to the internet. We developed this chip. It connects both to terrestrial cell sites and satellites also. You can send meter readings, GPS readings and all that to the internet. Build the chip. Now we are getting to mass production. That we intend to do in TSMC. That part is okay. If you have enough volumes, you can place an order, you get it, then the assembly and testing can be done in Taiwan or somewhere else. But then we found the bottleneck that we get the chips back. Now, now we have to work with what is called a module maker. So these are modules, little modules that go into other electronics. The module makers are only from China. Because they keep their assembly lines busy 24/7 and they got humongous volumes and they're the only ones who can offer you the price. So we have to solve this problem and there's no way you can do it in India. So we're hitting some hard problems. This is something to do with...
Especially in the semiconductor space.
That's even harder in semiconductor
space. We have gone way far behind in the last 20, 30 years.
And this is not just specific to India though, by the way. Anybody who does this, if they don't go to China, then they sort of have a trouble.
Yeah, just like our mission to start fabs, US has like, okay, we have set aside some 5,000 crores or whatever. They have set up some few hundreds of billions for it. But they're dealing with the same thing. They want to create capacity within the country, so your dependency on China reduces. Yeah,
So you need huge volume orders. That just doesn't solve the problem. You need that to begin with. And then you need domestic consumption that sometimes may not be enough. We have to export. So there's a long ladder to ride.
That's a completely new...
The chip is there,
yes.
but just to be able to sell, there's a barrier. But there will be some clever ways to deal with it. Find some partners, Japanese or somebody else.
Yes.
Forge partnerships, let them resell, white label, and then you climb the ladder. So there are other ways you have to do. You can't just solve it
Once you get that initial thing and initial market, then at least it opens up the possibility to expand. Reena, in the quantum space, do you see the collaborations between academic research institutions and industry? Like IIIT, given that it was founded with no government funds and there were 6 founding partners upfront, right? Motorola, IBM, Oracle, good names those days, and they had their schools here. Some of the industry thing has been steeped in our DNA from the beginning. Even so, active collaboration, solutioning collaboration is low, right? It stops somewhere. There are some companies like Intel fund research, right? Some go further and they don't fund research, but they fund solutions, concepts, and some even go complete end solutions. Not so often, but happens. But active solutioning is still low. Do you think in the quantum world, at least, since you see both sides very up close, right? Do you think industry is engaged actively with research at this stage of the whole evolution of that space?
The Indian industry, not as much as we would like it to be. So the engagement of the Indian industry with the Indian research institutes with real solid programs of developing things that will take the nation forward is not there. And like I said, I think it is a systemic problem. It is a cultural issue as well as a systemic problem. We cannot solve the problem by solving one thing or the other. The whole systems approach is needed. And in fact, QETCI has done a study, a 6-month study, where we created a quantum value chain report, which takes into account not just the supply chain, but a larger framework of value chain, because it's a nascent technology and an evolving one. So at this point in time, you are essentially looking at a non-existent supply chain, and you're trying to derive the supply chain from, on the electronic side, from whatever component manufacturing you are doing, whatever work is happening as part of the semiconductor mission, the infrastructure that has been built as part of the nanotechnology mission, and then there is this overlap between space and quantum. So what can you leverage on that front? So when you're looking at this kind of a scenario, it becomes important to understand that what kind of interventions will actually push the ecosystem forward when you have so much lack of clarity on the supply chain. So we did this study and we created a report. It's freely downloadable from our website. It's after we developed it, World Economic Forum told us that actually nobody has a framework like this. So they mentioned it in one of their reports as a best practice.
It's not an India problem, it's a much broader problem.
No, there is no formal documentation like this of a value chain.
Okay.
And quantum is new for everyone for this framework, saying how can we use it for even driving bilateral conversations. So that's a good thing. But what we did in this report, I'm mentioning it primarily because we took a systems approach to this. We are saying that you can't just fiddle around with certain parameters in the ecosystem and say that something good will happen. You have to look at the whole system and say, what are the systemic issues, as well as how can you, when you bolster one area, you want the impact in a certain area. For example, I'll give you an example. In order to be able to, let's say some of the hubs that are being, as part of the National Quantum Mission, there's supposed to be 4 hubs. One focused on computing, one on communications, one on sensors, and the 4th on quantum materials. Now, for any of these hubs are going to be led by research institutes. So people who are researchers and scientists and academicians. But at the same time, the responsibility that has been given to them is to think of the whole thing, because they have, the goals that have been given to them is things like, you have to create so many qubits quantum computer in the next 8 years. You have to create this much of capacity for the network, for how many kilometers worth of QKD networks or quantum networks, what kind of sensors with what kind of precisions will be available. So for the first time, the problem statement that has been given is very product specific. So now systems approach. So we are partnering with some of these entities and we are helping them understand that what kind of partnerships are needed to actually take this to conclusion. And that is possible only because you're looking at the whole ecosystem and not just looking at, okay, what do I need to do as the next step, right? So I believe that that's the way to go. We have to look at it from a systems perspective. Since it is Kohli Day today, I do want to mention that Mr. F.C. Kohli, and I was in TCS, I spent 22 years in TCS. He was the CEO when I joined TCS. And I remember so many instances when he was speaking or, when having meetings with people where I happened to be part of the meeting, he used to repeatedly say that we've done a lot in software.
managed to get some 40 crore grant. We're probably one of the first to get a private grant. It's possible because it's in a mission mode. I mean, they don't call it a mission mode, but it's kind of mission mode. So you have to get grants to industry. And you also have to give these grants to academia with no strings attached, in the sense that you give these grants, and then university also allows this IP developed to be used by faculty with no questions asked. Well, they could put something like, okay, give us 2.5% of this as royalty, something like that. Okay. This has worked beautifully well in China. The professors have built all kinds of different, I'm sure Silicon Valley, you know that better than anybody else. All the private universities, they have very little restriction on what could be commercialized. So we have a lot of barriers now.
Even in the new, like say in IIT Hyderabad?
No, we don't have that.
Yeah,
so I am actually
you probably made some of those things happen, policy.
No, I didn't. But actually, my first director made
Professor
this happen.
was a big advocate.
So, I mean, I'm able to do all these things. If not for him, I mean, it wouldn't have happened. So,
what's the royalty model in IIT Hyderabad? Royalty or equity?
Back then, actually there were no questions asked. You can do whatever you want. It was early days, right? You go see him and do something. And later on, when I was the dean, we introduced the innovation policy. There was a DST, not DST, there is MHRD guideline. We took that as a foundation, and our policy is fairly straightforward. A faculty is allowed to start a company at 2.5%. You take IP that you developed in the project, as long as the institute owns it, to that. And you can take unlimited amount of IP, and you can spend unlimited amount of hours with your company. You can do whatever you want, no questions asked, as long as you meet your basic obligations. This can be done everywhere, right? I mean, it's not
2.5 is very good. So
yeah, this is an MHRD guideline, but it's not written so.
So we are probably one of the more liberal ones, but we do 6%. But royalty,
it hardly matters.
6% equity or royalty, and most others are between, even the moderate ones are between 10 and 15%. And of course, this even in the US doesn't have a good policy.
Yeah.
Most universities, some universities have 60% royalty.
That won't work.
So they don't even commercialize. The professors go consult and build it elsewhere. A company funds a non-IP project. Once the project is done, takes the professor as a consultant and gets them to build it for them. Because they can't, there's no way they can license. But anyway, 2.5% is very good.
So, 2.5% is just the IP. But when you start a company, you have to give another 2.5, total is 5.
Yeah, for us it's 6% flat.
So it's not too far. Okay.
Yes.
But if you just do this uniformly everywhere, and half the problems are resolved, and no questions asked to the professor. Of course, if you have partners, you resolve among yourselves. And government should not poke their fingers into this. Their job is to give the money and keep the mission mode.
That's a good, they're trying in quantum and few other areas, but yeah.
No, I just learned recently that ISRO does it even more beautifully. They license out the technology. They have an agreement with the startup. After 7 years, the startup is free to do whatever it wants with it. It's free, completely license free.
So 7 years, but there are constraints.
7 years, there are some constraints. Because it is space technology. Actually, the startup benefits from those constraints because they are allowed to use most of the facilities and stuff like that. And then there are certain review parameters that they put in, which I believe would help the startup. That's why the sector has
last
taken
2-3 years, they've liberalized so much.
Right.
I think, again, partly because they come under the PMO, and PM has been pushing for this a lot.
No, but I didn't realize. I said after 7 years, yes, sir, after 7 years, it's completely, they can do whatever they want with it. That's how it should be, actually, if you want to push the technology. And the stake cannot be 60%, it should be 2%, 2.5, 4%, whatever.
I won't worry about these 2, 3, 4, 5. What difference it makes?
It should be small, but it can't be 20% or 50%.
As long as it's not controlling stake.
Yes.
As long as it doesn't exceed, let's say, 10.
Right,
Yeah.
right.
What difference it makes?
Stanford is 10%.
No, it should not be 20%, 60%.
So
is what
Stanford,
I'm saying.
best known in the world, is 10%.
Right.
When Stanford technology gets licensed and to anybody, not just a professor, anybody, it's 10% equity they take.
And by the way, we give exclusivity. With this equity, there is exclusivity.
Which is expected, yes.
This is something we enforced. I mean, that's the stickiest point. All the government guidelines, they have a long list of rules. To give exclusivity, they say it should be rarest of cases. They use some funny words.
No, but that is very restrictive, actually.
So, I mean, the moment you give non-exclusive.
I know, the competitive advantage is lost if you don't
do something good, it's dead.
Yes.
So it's as good as dead. So this has to be fixed. I think
the rest of things will follow. But again, it's up to the professor, student.
True. This is today.
We can't give a prescription for such.
Exactly. It's not an enabler, it's a disabler today. You remove the impediment at least. By having reasonable IP policy, you remove that impediment. It still create an environment. So, Sir Pradeep, you're asked, what do you think will help get you? I know you've been working with some of our professors and other places. Agri, you work with Agri University. Your experience from the other side, what do you think will help? One thing that you see that will get more of research out into the field.
So, on the commercialization front, I would honestly say I have a rather pessimistic view as on date. It will certainly change to be an optimistic one, I hope so, but irrespective of all Make in India schemes that are there, just 2 days ago, we were waiting for a shipment from China for our raw material. So we do design and build our own drones in-house, but the raw material, quite a bit of it still comes from outside, be it China, Taiwan, US and Europe. In the last 1 month, I started hearing, and our shipper clearance agent in China said, China has taken a decision to restrict all UAV part exports overnight. There was no single notification or document to that, but the customs officers are enforcing it. So radio parts and even simple motors, aluminum parts, my customs handling agent, CHA, what we call, those guys said we are not able to deliver it on time. And when I went into the depth of it, it says there's no document, but still these guys are not getting exports. And this is where significant amount of production in India, at least on the commercial applications, was still dependent. I would say more than 90%